By the end of this video, you're going to be feeling much more confident with these SAT math problems. We're going to be going over 50 of these problems in this video, and before we get into this, here's everything that you need to know about this video in under a minute. As the video goes on, these problems will get more and more difficult, so especially early on, if there's a problem you feel comfortable with and you want to skip to the next problem, I have the timestamps for every single problem right in the play bar. Also, the calculator problems for this video will be marked with a little c. Early on, we do a lot of no calculator problems with some calculator problems mixed in, but the last 20 problems are almost all calculator problems. Now, I do have a printable problem sheet and answer key for this video linked right in the description. I know a lot of you have been asking me to do that for this new video, so I made it happen, and I also added a little QR code on the notes that can take you back to this video. And of course, you're going to get questions as you go throughout the video, so ask whatever questions you have in the comments. I'll get back to you when I can. And if you're looking to review harder SAT math problems only, I have another video where I do 25 of those. And lastly, I'll talk about these guys later because I think it's about time we get into this video. So let's try and get through these first 5 problems and then I'll give you a break. So let's start off with problem 1. Problem 1 says that Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? Now, something I like to do whenever I finish reading a word problem is just underlining what it's actually asking for. And the reason for that is because, I don't know if this happens to you, but for me especially, after I read a word problem, I just forget everything I just read. I'm just like, wait, what? So I think a great way to start countering that is to underline what the problem's asking for, and then you can ask some other questions from there. Like here it says, what is the meaning of the value 108 in this equation? Well, what equation is it referring to? Well, the P equals 108 minus 23D. And if you want to know what P and D mean, well, it tells you that later in the problem. So that's how I like to start dissecting these problems. And if you notice here, the equation that it gives us is the equation of a line. We can rewrite this as P equals negative 23D plus 108. And that's how you generally see this equation written, right? With your slope first and your y-intercept second. And you'll notice what I just said here. The 108 is the y-intercept. So what does the y-intercept mean? Well, the y-intercept of a line is your starting point. And if you don't understand why it's the starting point, I can talk about why that is in a second. But the line also has another aspect of it, has the slope. Because you not only need a place to start from, but you also need a direction. The slope tells you the rate of change. It tells you whether your line is, looking like this, if it's going up really fast, if it's going down kind of slow. That's what your slope will tell you. And just with this information right here, if you understand that 108 here is your y-intercept, and you know that the y-intercept is a starting point, you already know that the answer to this problem is choice B. And the reason for that is because we'll look at the other question, or the other answers. Choice A says Kathy will complete the repairs within 108 days. That says nothing about starting something, so no. Choices C and D are talking about rates. Well, the rates, that would be talking about the slope. And if we wanted to talk about the slope, we'd need to be talking about the negative 23. So it's not those answers here, but choice B says Kathy starts each week with 108 phones to fix. And that works with what the y-intercept is. So you might get the gist of what I'm saying here, right? The y-intercept is the starting point, so we know how to solve this problem. But why is the y-intercept the starting point? That might be a question that you still have. So let's talk about that in the context of this problem. So we can see here at the beginning of the problem, each week, Kathy is receiving a batch of phones that need repairs. So at the start of each week, right, starting point, at the start of each week, 0 days have passed. That means that D is equal to 0. And since 23 times 0, that's 0, P is equal to 108. So what we have just done here is we found how many phones that Kathy has to fix at the start of each week. That is the significance of the y-intercept. It's telling you where you're starting from. Okay? So if you understand that, then I think it's clear for us to move on to problem 2. Problem 2 says that a pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So, again, what is that word problem actually asking for? Just because, probably most of what you just read went right in one year and out the other. This problem is saying, based on the model, what is the estimated increase in inches of the boy's height each year? So we're looking for that keyword is increase. And here, since we have a line that we're starting with, we know that the increase, that rate of change, is the slope, right? We're talking about the slope of this line. And the slope here is 3. So that would get you to believe that the answer here is choice A. But you might want to check the units on that, just to make sure. The units for slope, or just slope in general, is change in y over change in x. Here, that y is an h, and the x has an a there. And what are the units on both of those? Well, the h, the height, is measured in inches, and the a is the age, that's measured in years. So it's being measured in inches per year. And so this 3 right here, right, the slope here we know is 3. So the slope is 3 inches per year. And that's exactly what we want here. We want the change in the boy's height each year. So the slope here is not representing years per inches, so we're safe, right? We know that the answer is definitely 3. So moving on to problem 3 here, we have that the function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? So based on this table here, which just gives us a couple points on this function, on this graph, we're looking for which of these guys are a factor of f of x. And so, well, what are the factors actually tell us about a graph? Well, the factors, like let's say we have just some quadratic. All right, something like this. The factors, which in this case would be x plus 2 and x plus 3. The reason why these are useful is because it tells us where the y is equal to 0. Right? So if we want to figure out where the y is equal to 0, we can see right here that that's going to happen where x is equal to negative 2, because that's going to give us a 0 here if we plug in that x is negative 2. And 0 times anything is 0. And we also know that x equals negative 3 would work here. Because if you plug in a negative 3 here, you're going to get a 0, and 0 times whatever this guy is going to be 0. So factored form points out those places. It points out the zeros, which are the x-intercepts. So you know you're looking at, either this guy or this guy, right? Where something is 0. Remember, these guys are points where y is equal to 0. I have that written right up here, right? It's where we set y equal to 0. And if you think about that a little bit better graphically, just so you don't have to, go through all this conceptual mess that I just put you through. Think about your xy axes. Right, where are the zeros? The zeros are right here. At both of these points, is y 0 or is x 0? Well, y controls how far up or down you are. And here you're right in the middle. So that means y is equal to 0. Okay? So you can think about that either way that you want to. But since you know that you're looking for where y is equal to 0, you see that happens when x is equal to 4. And what's the factor that corresponds to x equals 4? Well, it's going to be x, not plus 4, it'll be minus 4. Because remember, we're trying to get this factor to equal 0. Right, like here, we want that x plus 2 to equal 0. So we're asking what value of x will make this thing 0. And that would be negative 2 in this case. And in this case, 4 would be the value of x, because then you get a 4 minus 4, which is 0. So that's why we always flip that sign there. I know a lot of people are always confused on why the heck we do that. So x minus 4 is going to be the answer here. All right, for problem 4, this problem says if a over b is equal to 2, what is the value of 4b over a? And so there's a lot of different ways that people like to solve this problem. A lot of people, I've done this problem on TikTok before, and so many people just argue about what way is the best to do it. There's 3 different ways I can think of to solve this problem. I'm going to show you just one way to solve it. And if you have a different way that you like better, let me know what it is in the comments. But here's how I would go about solving this problem. Or at least the easiest way I could explain how to solve this problem. You can just solve it like a substitution. So I can solve for a here really quick. I can just multiply b on both sides. And that will give me that a is equal to 2b. And if I have that, I can plug that into 4b over a. Because that'll get everything in terms of one variable now that I have a in terms of b. It's just like substitution method when we solve a system of linear equations. So this becomes 4b over a is now 2b. And from here, the b's cancel. You're left with 4 divided by 2, which is 2. And that is choice C. All right, so that's the answer there. Now moving on to problem 5, this is actually the first of our calculator problems. So you see that C up in the top right. This problem says, for what value of n is the absolute value of n minus 1 plus 1 equal to 0? And I think a lot of people, they get confused when solving absolute value equations because that's not something that you do very much of. You cover it once in Algebra 1 and then never talk about it ever again. So let's review a little bit of that. Here, we have that the absolute value of n minus 1 plus 1 is equal to 0. And if we want to start solving this for n, what we want to do is get this absolute value by itself. So anything that is not in the absolute value has to go to the other side. We can get it to the other side, that plus 1, we can get that to the other side by subtracting it on both sides. And that will give us that the absolute value of n minus 1 is equal to negative 1. But this right here poses a problem, doesn't it? Because, well, the absolute value of something can't be negative. That should be an issue that you see right away. That's not a thing. So no values of n can make this work because just by definition, you can't have the absolute value of a number being negative. And so the answer here would actually be D. There's no value of n that could make this happen. I know a lot of people, I get this way a lot. I'm not sure if you get this way too, but I always am so hesitant to have the answer be, there's no possible way this could happen, right? I don't want to have that be the answer. I want to figure out how to actually make it work. But here, there's actually no way to make it work. So, yeah, that's the answer here. But something you might still be wondering is, okay, well, if this did work, if I was able to solve this, how would I go from there? So let's talk about that. I'll give you an example you could solve. Let's say that we had the absolute value of x minus 1 is equal to 3. Okay, how would we end up solving this? Well, first off, we do have that absolute value that is by itself. That's exactly what we want. Everything that's not in the absolute value is over on the other side. Well, what we would do at this point is, well, look at this equation. Whatever is inside the absolute value needs to be one of two values to make this equation true. This could be a 3, because the absolute value of 3 is equal to 3. That would work. But if this x minus 1 here was a negative 3, this equation would still be true, because you have to take the absolute value of it. And if you did that, you would get 3. So that x minus 1 there, the thing that is inside the absolute value, could either equal 3, or it could equal negative 3. And you can solve both of those equations here just by adding 1 on both sides and get your values of x. So here you would get x is equal to 4 and x is equal to negative 2. Okay? So that's all because, like, once you get to this point, you look and you see, oh, well, what's inside this absolute value here could be a negative 3 or a 3. Because when I take an absolute value of both of those numbers, it could be a 3. And you split that up, you solve these two equations, and that will give you your values of x. So here's an example where you can't solve it. Here's an example where you can. And so that's how to deal with absolute value equations on the SAT. So that does it for our first set of 5 problems here. And so at this point, I would just take a quick break. I'm not sure how long we've been going here, maybe like, I don't know, 12 minutes or something like that. But take a quick like 5-minute break or something like that and get back into this next set of 5. So assuming that you've taken that break, let's move on to our next set of 5 problems for this video. So for our next problem here, problem 6, this problem says the line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point c comma d, where c and d are both not equal to 0, what is the slope of the line in terms of c and d? So what are we trying to find here? Again, let's underline that. We're trying to find the slope of this line in terms of c and d. This line is y equals kx plus 4. So how do we find the slope? Well, the slope is found using the slope formula. The y2 minus y1 over x2 minus x1. We need 2 points to find the slope. In this problem, though, we're given the 1 point. We're given if the line contains the point c comma d. So we know that that's a point. I'll write that up here. We know that that's a point, but what's our other point? That's where the problem lies here. We have to actually find that other point. And it's a little bit tricky here, but the other point comes from the equation itself, y equals kx plus 4. Because the y-intercept gives you a point. If I draw my xy axes here, we know that this line crosses the point 0, 4. We know it's got to cross this. We don't know what the slope is, but we know it at least crosses this point. And the coordinates of this point are 0, 4, not 4, 0. And that is my other point. So which one of these should I call my first point? Which one should I call my second point? It doesn't matter. You'll get the right answer either way. I can actually show you either way. But I'm going to go and put this guy as the second point and this guy as the first point. And you might be able to tell why I'm doing that if you look at these answers, but you'll be able to see that as I go through here. So again, we know the slope is y2 minus y1 over x2 minus x1. I think I accidentally erased that. And the slope is going to be, well, y2. The y-coordinate of my second point is d. The y-coordinate of my first point is 4. The x-coordinate of my second point is c. And the x-coordinate of my first point is 0. So all in all, I'm going to get a d minus 4 over c. And that right there is equal to choice A. So that's my slope. Now, what would happen if you called this guy your first point, though? Because some people might do that, and it probably would make more sense that way since this is the first point that we found. So if you did that, I'll write this here. So if you did this is your first point, this is your second point, what would happen is you would get, well, the y-coordinate of your second point is now 4. You would get that minus the y-coordinate of your first point, that's d. And then you would get the x-coordinate of your second point, that's 0. And then the x-coordinate of your first point is c. So what you would end up with is a 4 minus d over negative c. That's not yet the same thing as d minus 4 over c. Right? It doesn't, or at least it doesn't look like it. So what do we do? How do we get this to look like this? Well, what we can do is notice, hey, this denominator is negative, and if you look at all our denominators here, they're all positive. So why don't we just multiply by a negative 1 over negative 1, right? We multiply by a negative 1 on the top and a negative 1 on the bottom. If we do that, that's going to give us a positive denominator. And in the numerator, If we multiply -1 to the 4, that'll give us a -4. Multiply the -1 to the -d, that gives us a positive d. And so now you get -4 plus d. You're almost done. Just switch the order of these two. And that gives you your answer. So it's a little more work if you do it that way. And the reason why I chose to pick it this way, now you might be able to see this, is because I knew that if I picked it this way, I would get a negative in the denominator, right? You can kind of see how these would go if you get comfortable with this. And so I'm like, yeah, I don't want to deal with that. So let's make this guy the second point. And that way my denominator ends up being positive. So just something to watch out for. So moving on to problem 7 here, this problem says, what is the solution x comma y to the system of equations above? So we've got this gross looking system of equations, and they're already trying to trick you here. They're already doing something to trick you, which is kind of annoying, to be honest. What they're doing, and by the way, this is not a calculator problem, sadly. What they're doing is they've switched the x's and the y here, so that they're assuming that, you'll make the mistake of putting this as 2x instead of 2y. They're cheap that way. So what we're going to do is we're going to switch this order. Okay, we're not going to get tricked by them. The negative x is going to go first, and then the positive 2y is going to go second. And this is equal to -19. So we can solve this problem. There's a couple different ways that we could go about it. There's substitution method, there's elimination method. And honestly, what I would do here is just solve this using elimination method. I like using elimination most of the time, and unless there's like an easy substitution I can do. So what I'll do is I can see that these y's can be canceled out pretty easily if I just multiply by a -2 on both sides on the bottom equation, because if I do that, that's going to give me a -4y here, and that will cancel out with the 4y. Okay, you'll see that in a second, especially if you're rusty with systems of equations. You might not understand what I'm really getting at yet. And so the top equation stays exactly the same. It's still the 3x plus 4y equals -23. The bottom equation is now -2 times -x. That's a positive 2x. Then we have a -2 times 2y, which was the -4y that we wanted. And then this side is -19 times -2. That's going to be a positive 38. So now what I'm going to do is add these two equations together. And the reason why, in case this is still random to you, why can you add two equations together? Why does that even make sense? This is just the same thing as you've always been doing. Like when you have an equation, x plus 3 equals 5, and you solve it by subtracting the same thing on both sides, right? Subtracting 3 in this case on both sides. Here, I want you to realize that you are adding the same thing on both sides of this equation. On the left-hand side, you were adding a 2x minus 4y. And on the right-hand side, you're adding a 38. That's the same thing as adding something on both sides. How do you know that, though? How do you know that this guy is the same thing as this? Well, it's because they're equal. That equation says that. So you're quite literally still adding the same thing on both sides. That's why we're able to add or subtract equations. And I didn't know that for like the longest time when I was in Algebra 1. I didn't really get that that's why we could do that. So when we add the 3x to the 2x, we get a 5x. These guys cancel out because 4y minus 4y is 0. And so 5x is equal to this guy. It's a 38 minus 23. That will be a 15. So we can just divide by 5 on both sides. That gives us that x is equal to 3. And there's only one solution where x is equal to 3, so we already know what the answer is. So that works. And if you wanted to solve for y here, you shouldn't, right? You shouldn't. At this point, you should be done, unless you have time to go back and check your answers. But you can take one of these equations and just plug in what you have for x. Sorry, this should be an x. Plug in that x is 3, so do 2y minus 3 is equal to 19, and then solve for y. You'll be able to see that it's -8. So that's a way that you can do it. if you are struggling, if you don't know how to solve something using system of equations, if you forget all of a sudden, it's fine. What you can do is start plugging your answers in. Plug in -5, -2 into both of these equations and see if it works. And then move on to your next point. Because if you plug in 3, -8 to both of these equations, it will work, meaning you'll get the same thing on both sides. So there's that backup plan. If you don't know how to solve system of equations like that, you can always just plug in answers, and honestly, they both probably take like similar amounts of time. So moving on to problem 8, this is another problem that involves a system of equations, but this one is a little bit harder. This problem says, in the system of equations above, k is a constant and x and y are variables. For what value of k will the system of equations have no solution? Now, the big key to this problem is that this system is going to have no solutions. And I think when a lot of people, they start deviating from like the regular one solution, they start talking about no solutions and infinite solutions. Now they start to get in trouble. They start to forget absolutely everything that they learned because it's been a while. It's been, maybe 1 or 2 years for you since you've actually talked about that stuff. So as a quick recap of what systems of linear equations actually are, here is an xy axis here. Okay, here's your xy plane. And usually, what happens with a system of equations, so like here's a system of equations. These two are lines. You can convert them both into y equals mx plus b form, and let's say that you graph them, they'll most likely intersect at a certain point. And that point that they intersect at is called the solution. You're trying to find where these two lines intersect. That's what we do in this problem here, in problem 7. These two are both lines, and we found where they intersected. That's what goes on here. But these lines don't have to intersect. These lines can be parallel to each other. And now you start to get in trouble, because these two lines are parallel, so they'll never intersect. And this is an example of no solutions. And the important thing to know about a system of equations which has no solutions is that these two lines have the same slope. That's actually what we're going to use for this problem here. But before we do that, I should also note that if these two lines are right on top of each other, they're still parallel, right? They're still the same slope, but now they're right on top of each other. They're now going to intersect at every single point. Right? They're on top of each other. They're always going to be on top of each other. That is what infinite solutions is. So now they, instead of just having the same slope, they have the same slope and the same y-intercept. And that is a difference between no solutions and infinite solutions. And while I erase this here, I should note, if you want to learn more about like actually solving systems of equations, which also can appear on the SAT where you have no solutions and infinite solutions, like you need to see the 0 equals 0 case and the 0 equals 2 or something like that, I have a full YouTube video where I go over all of that. So let's actually get back into this problem here. Remember, for no solutions, okay, if we have no solutions, that means that these two lines right here have the same slope. That's what piece of information this gives us, because without it, there's no way that we can find k here. So if we know these two lines have the same slope, then we can find the slope of each of these lines, and we can set them equal. That's how we're going to be able to solve for k, and you're going to see that. So let's start off by finding the slope of kx minus 3y equals 4. We got to get that into y equals mx plus b form so we can see what the slope is. To find that slope, let's subtract kx on both sides. Got to solve for y here. So we're going to get a negative 3y is equal to a negative kx plus 4. I'll write that x term first like you're used to seeing it. And then we're going to divide by negative 3 on both sides. And that's going to give us that y is equal to, they're both negative, so this is going to be a positive, k over 3. I'll put the x here. You can leave the x up here, but I like to put it separate. It's still the same thing, but the reason why I like to keep it separate is because now you can see clearly what your slope is. And then we have a negative 4/3 right here. So great, we get that. That works. We know our slope is k over 3 for that line. What about for the other line, for the 4x minus 5y equals 7? Well, now we subtract 4x on both sides to solve for y. We get negative 5y is equal to a negative 4x plus 7. And we divide by negative 5 on both sides to finally solve for y. So we get that y is equal to, this will be a 4/5 x, and then this is a -7/5. Now that we have that, we again know that these slopes are equal to each other. They are the same. And so k/3 must equal 4/5. So now that we know that, let's just cross multiply, and that'll allow us to solve for k. We get that 5k, or actually, no, let's not cross multiply. That's way too much effort. Let's multiply by 3 on both sides. Because if we multiply by 3 on both sides, then the 3's go away, we already have k solved for. So we get that k is equal to a 3 times 4, which is 12, divided by 5. So that's going to be a 12/5. And that is choice A. All right. So that's the key. When you think about no solutions, they have the same slope, but they have different y-intercepts. And you can actually see here even, they do have different y-intercepts, -4/3 and -7/5. If these two lines, if we were looking for where they had infinite solutions, then these two y-intercepts would have to be equal. That can't happen here, but if, there's problems with even more constants involved, which I have seen before, then just remember you also have to set the y-intercepts equal if there is infinite solutions. But yeah, that's this problem. So moving on to our next problem here, problem 9. This problem says for the function g defined above, a is a constant and g of 4 is equal to 8. What's the value of g of -4? So you might be able to solve this problem in no time at all, in 5 seconds, because you can see that this is an even function. So g of 4 would need to be the same as g of -4. So since this guy's 8, this needs to be 8. And that means that your answer is choice A. All right, moving on. No, I'm kidding. So yeah, obviously some of you are going to be confused with, first off, what's an even function? What does it mean to have an even function? How do I know that I have an even function? and all that stuff. So we're going to go through that. And if you don't even think about this whole even function thing at all, I'm still going to show you how to solve the problem anyway, without knowing anything about even functions. So let's talk about this. First off, I can tell that this is an even function because it only has even powers of x. This term also is an even power of x because with 24, right, I can write this as ax squared plus 24 times x to the 0. So x to the 0 is just 1. So this is completely fine to write it like this because this will be 24 times 1, which is still 24. And here we have an even power of x. So again, it's all even powers. That's how I know we have an even function. And an odd function would be only odd powers of x. Now an even function has symmetry about the y-axis like this. So if we know that the y value at x equals 4 is 8, then if we want the x value, we want the y value at x equals -4, it's got to be the exact same thing because it's got that symmetry. So that's how I can show you that with the symmetry argument. But what if you don't know that? That's not something that comes to your mind right away. Well, we can solve this algebraically too. So what we can do here is say, okay, well, I know that g of 4 is a times x squared, which I can write as a 4 squared plus 24. And this guy's equal to 8. From here, you can solve for a. And by the way, from here, you can also see that if I was doing g of -4, and I plug in this -4 for x, it gets treated just the same as 4 does because it gets squared. And what that means is that the negative drops. So this right here is a times 16, and this guy is also an a times 16. So there's another clue that g of 4 is the same as g of -4. But if you miss that too, if you don't see that, you can still solve this problem. Okay, so I'm giving you all the clues to solve this a lot faster, but if you don't see it, here's how to go. You can solve for a. You can say that this is 16a plus 24. That's equal to 8. Let's solve for a. We subtract 24 on both sides. We get that 16a is equal to a -16. Divide by 16 on both sides, and you get that a is equal to -1. So there you go. You have your value of a. And then plugging in to g of negative 4, you know that it's going to be ax squared plus 24. But here you know that a is a negative 1. And then x squared, that'll be the negative 4 squared, since you know you're plugging in a negative 4 for x here. Then we just add on 24. So this becomes negative 1 times 16, which is negative 16, plus 24, and that's equal to 8. So you see the g of 4 is 8 here. So that is the very long way of solving this problem, but again, this work is not necessary. If you realize this is an even function. So if you realize that g of x is even. All right, so that is problem 9. Now we're going to move on to our last problem for this set of 5. So we'll have 10 problems done. That'll be great. So this problem says, in the xy plane, the parabola with equation y equals x minus 11 squared intersects the line with equation y equals 25 at 2 points A and B. What is the length of the segment AB? So this problem is going to leave you clueless if you can't visualize what's going on here. So you're going to need to know a little bit about how graphs transform. I'll show you this. So if we want to visualize what's going on here, we have two curves. We have a parabola, this guy, and we have a line. So how do I draw x minus 11 squared? Well, if you just were to draw x squared, that's a parabola, just like normal. You've got your vertex right at the origin. But if what you do is you take this square, or you take what's inside that square, and you subtract 11, what that does is it shifts it either left or right. Here, since you're subtracting, it actually shifts it to the right. That's what it will do. And I'll just not exaggerate that as much, so I'll draw it that way. The reason why you have to do the opposite, like you would think subtraction moves it to the left and addition would move it to the right, but the opposite happens. The reason for that, let's think about this parabola here, right? Let's think about where your y would equal 0. That's this point right here. Where on the x-axis would your y equal 0 for x minus 11 squared? Well, if you set this thing equal to 0, you can see that the only x value that you could plug in here that would make this thing equal to 0 would be 11, because then you'd get 11 minus 11. So that's why this moves to the right, not to the left. That's how to check yourself on that. But if you are, let's say, adding a number to this, right? So let's say that you have x squared plus 3. Okay, that is your same parabola, but it is moved up by 3. So this adding will move it up, subtracting will move it down. That will do exactly what you expect. It's only when you put things in the parentheses that they do the opposite. So that's that little bit of explanation out of the way. And now all we need to do is graph y equals 25. So I'll just graph that as some line coming through here. What that will do is give us our points, A and B. Those are the two intersection points. And what we're trying to do is figure out what the length is of this segment right here. So how do we do that? Well, if we find the x-coordinates of this intersection, then we can just subtract them, right? Because the distance here is the same as the distance here. So that's exactly what we want to do. Let's find the x-coordinates of the intersection. Let's subtract them. And to find the intersection, all you have to do is set these two equations equal to each other. We know that y is equal to this and y is equal to this. Therefore, if we want to find where they intersect, we want to know where they're equal to each other. So to solve for x here, let's just square root both sides. When you square root this side, it cancels out with the square, so you just get x minus 11, and then square root of 25 is 5. And when you square root both sides of an equation, you need to put a plus or minus on one of the sides. So here, I'll make it a plus or minus 5. Okay? So now I can just keep solving here by adding 11 on both sides. And that will give me that x is equal to a 5 plus 11. And it also gives me that x is equal to a negative 5 plus 11. And so x is equal to 16, and x is also equal to, that's a 6. So we know the x-coordinate here is 16, the x-coordinate here is 6, and therefore the distance between them would be 16 minus 6, and that's 10. So there you go. That is your next set of 5 problems. We now have 10 problems done, and we've got a lot to go, but at this point, I think it's a good idea for you to take a just quick 5-minute break, get some water, go stretch, do something, because you're not going to want to sit and just try to watch all of these, because your mental capacity is just going to go down and down and down, and it's not a good idea. Okay, so take a quick 5-minute break and then come back to the video. We'll get another set of 5 done. And assuming you've taken that break, let's hop into the next set of 5 problems for this video. So we're going to start with problem 11. And this problem says, in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So this is what the word problem is asking for. And all right, I just want to address a little pet peeve before we keep going on here. I don't understand why the SAT does this. Look at how this was a 2-sentence paragraph. Look at how long that sentence was. That is a run-on sentence. That is the dictionary definition of a run-on sentence. If the SAT is going to assign an English section, you would think that they would follow those rules when making their math problems. Just a thought, right? That should probably happen. But anyways, when we're in this problem, this problem is asking for the price per pound of beef when it is equal to the price per pound of chicken. So we're saying B is equal to C here. Those are the price per pounds that it gives us earlier in the problem. And we want to know, well, what's the value of these guys when they are equal? So if we know that B is equal to C, all right, let's set these two equal to each other. 2.35x, nope, already wrong. 2.35 plus 0.25x is equal to 1.75 plus 0.40x. And now we just solve for x. So I'm going to subtract 0.25x on both sides, get all my x's to the right-hand side. Some of you may not like that I'm going to the right-hand side, not the left-hand side, but I don't want negatives, so sorry. This right here is 0.6. This guy is 15, so it's right there. And yeah, this is not a calculator problem either, so you gotta do that. And so now we just divide by 0.15 on both sides. This is easy to do division. I mean, it's the same thing as 60 divided by 15, which is 4. So x is equal to 4 here. Now, you'll notice that is not the answer here, because what we're asking for is not the time when B is equal to C. We're asking what the price is per pound when B is equal to C. So we've got to plug this x equals 4 back into one of these two equations. So I'm going to plug into the B equation, actually, because it's going to be really nice if we multiply this guy by 4. All right, so B is 2.35 plus 0.25 times x. If we plug in that x is 4, then I can write it like that. And so this is 1, and this is 2.35, so that's 3.35 when you add those two together. And that is going to be your answer. So that's all you got to do for that problem. It's actually one of the nicer system of equations problems that we've done in this video. All right, moving on to our next problem here, problem 12. This problem is a little bit geometrical. We got to deal with angles here. It says in the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? And we're given a bunch of statements that may or may not be true here. So first off, you might see that we have a bunch of vertical angles going on here. So we know that y is equal to u. We know that z would equal w. We know that t would equal x. And that's just to start. Those are the vertical angles. Now, even though it looks like, z and x would probably equal each other, and, y and t, like, just because they look the same. It looks like all of these angles are exactly the same. But we can't assume that. It says figure not drawn to scale. So where do we go from here? Well, we also have this equation that they gave us in the problem. So, that can help as well. We know that x plus y is equal to u plus w. And you might be able to see here, we already know that y is equal to u. This is the same thing as this, which means that x needs to equal w. Because these two things are not going to be equal if x doesn't equal w. Think about it. If y is equal to u, these two are the same exact thing. Like, that's kind of the same thing as like x plus 3 equals 3 plus w, right? These two are the same thing, like I was saying. So if we subtract them off on each side, we get that x is equal to w. That's why that makes sense. So if we know that x is equal to w, well, we also know that w is equal to z. And we know that x is equal to t. So now we know that all four of these guys are equal. So where do we go from this? Well, let's start looking at our statements. X is equal to z. Do we have that? Well, yeah, we do right here. So that's going to work. What about y equals w? Well, I don't see that anywhere. I don't see anything that would equate y to w, so we can't really say that yet. 3z equals t, we do have that. So that works. But what about this y equals w thing? Is there any way that we could figure this out? I mean, you could probably start saying, oh, well, we know that x plus y plus z is equal to w plus u plus t because they're supplementary angles. I mean, but that's not going to get you anywhere, right? You're not going to be able to do anything else. And you can try, but I mean, there's nothing else you can do. And if you've tried for a while and there's nothing else that you could think of, just call it quits. All right, it's probably not that as hard as you're making it out to be. So 1 and 3 is going to be the answer here. And that does it for problem 12. Oh, that's not, nope, 1 and 3 is here. That's going to do it for problem 12. So moving on to problem 13, this problem says a line in the xy plane passes through the origin and has a slope of 1 over 7. Which of the following points lies on the line? So let's think about this here. We have a line in the xy plane. So let's bring out an xy plane. And let's just draw a point at the origin. We know that's a point that is on this line. We also know this line has a slope of 1 over 7. So does that mean that if we do our rise over run thing, we're going to end up at 1, 7? Well, no, not quite. And that's kind of a little bit of a trick to this problem. They would get you to assume, oh, well, if it's a slope of 1/7, then we'll end up at 1, 7. But that's not quite right. Remember, with the slope being rise over run, that means we're going to go up by 1 and over by 7. The point that we end up at is not 1, 7. It's actually 7, 1. Because the x-coordinate is not a 1, it's a 7. So that's how we get to the first point. But, I mean, you can see here that doesn't match any of our answer choices here. So where do we go from here? Might be a little confusing, right? Well, let's go one more over and see if we can get any of these answer choices. So if we go up by 1 over by 7, again, we end up at 14, 2 this time. So choice D is the answer here. Moving on to problem 14, this problem says based on the histogram above, of the following, which is closest to the average, arithmetic mean, number of seeds per apple? So we're trying to do an average off of this histogram. And that might be a little confusing to you because usually when you're trying to think about averages, you're given some list, like something like this. And they're like, okay, find the average of this. So how do we find the average of a histogram, well, we can turn the histogram into a list. And if you think about what we're trying to average here, it would make sense how we would turn it into a list. What we're doing in this histogram, if you look at it close, we are taking 12 apples, and we're finding the number of seeds in each apple. The results are plotted in the histogram. And what we're trying to do is average the number of seeds in each apple. So what we'd want to do is we'd want to add up the total number of seeds and divide by the number of apples. So that's how we would go about doing this. But, well, how do we find that total number of seeds? We can just form a list if you want to. I'm going to show you a quicker way to do it, but if you wanted to start making a list, you can. So we see that we have 2 apples where there are 3 seeds. So we could write that as 3, 3. There you go. You have 2 apples with 3 seeds. You have 4 apples with 5 seeds. So you would write 4 5s. And you could make your list that way. And then eventually, when you're actually trying to compute the average, you would add these all up and everything that comes after it. But instead of doing that, I'm going to show you a little bit of a quicker way. We have 2 3s. So instead of writing that as 3 plus 3, let's write that as 2 times 3. And instead of writing 4 5s, let's write it as 4 times 5. And if we keep going there, there's 1 apple with 6 seeds. So we write that as 1 times 6. We have a 2 times 7 and a 3 times 9. And we're putting that all over. It's not 5 things that we're adding together. This is a compact way of writing all of the different pieces in the list. Because there are going to be 12 of these. How do I know? Because there's 12 apples that we were looking at. So this is going to be divided by 12. And now you can put this in your calculator. This is a calculator problem. But what I'm going to do is just limit the amount of thumb work that I need to do. I'm going to just do this numerator part in my head. First we have 6 plus 20 is 26. Plus another 6 would be 32. 32 plus 14 is 46. And 46 plus 27 is not going to be a 63, it's going to be a 73. So it's going to be 73 divided by 12. And so now we just need to put that in our calculator. If you do that, you get 6.083 repeating, I believe. So you get this guy, and that might make you think you did something wrong because it's not one of these numbers. But reread the problem and it says closest to the average. So we're not trying to find... I really wish I would not get emails while I'm recording my videos. Like, I thought that I turned it off. It appears that I haven't. So, all right. Anyways, so the average, the closest number to the average is going to be choice C, which would just be 6, because this guy is about equal to 6. All right. So that is it for problem 14. Now moving on to problem 15, the last problem for this set of 5. This problem says in the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex c comma d. Which of the following is equal to d? So, what are we trying to do in this problem here? We're trying to find the value of d. And what is d being defined as? It's saying that it is the y-coordinate of the vertex. Now it does give us the equation of this parabola, which is really nice. So, I mean, this equation does give us some pretty good information. It tells us where the zeros are for this parabola. So I can graph this and just give you a good understanding of what this thing is going to look like. So we know that there's going to be a 0 at x equals 2 and a 0 at x equals negative 4. So let's do that. We'll put a 0. This is going to be probably about where 2 is. This is going to be about where negative 4 is. So if I was to draw a parabola, let's see if I can get this on the first try. All right, not good, but it'll work. So great, there's your parabola. And I don't know if it's facing upwards or downwards because I don't know whether a is positive or negative. The only thing it tells me about a is that it's non-zero, which means that it's, not 0. So that's great. That's a good start. Now we want to talk about the vertex. And what I want you to understand about this is that parabolas are symmetrical. That means if you want to find the vertex, all you have to do is look in between the zeros. Look at the middle number in between the zeros. The vertex is going to fall at x equals -1 because it is the middle number in between -4 and 2. If you think about this as -3, -2, you got 0, and then you have 1 over here. I know that this is -1. I know that's the middle number because, well, 1, 2, 3, 1, 2, 3. If you don't like doing that, if you just want a better way of doing that, you can average the two numbers. So -4 and 2, I'll average them by adding them together and dividing by 2. And that'll give me -2 divided by 2, which is -1. So what that gives me, the middle point there, gives me the x-coordinate of the vertex. So that's nice if it gives me that, but I want the y-coordinate. I don't want C, I want D. So, well, if I know the x-coordinate of the vertex, I can just plug that in to the equation for this parabola, and that'll give me the y. So let's do that. Y is equal to a times x minus 2 times x plus 4. Plug in that x is equal to -1. And what we end up getting is a times -3 times 3. And multiplying those together, we get that y is -9a. And that right there is choice D. Or sorry, choice A. What? It's choice A. So that's just something you got to understand about parabolas, how they are symmetrical. I think a lot of people get confused with that concept, but that's just a property of parabolas. So that is going to do it for our third set of 5, I believe. Yeah, it's our third set of 5. So go take a break. And while you're taking that break, if you're looking for more help with the SAT math section and you like how I'm explaining things so far, then I have good news for you because I have my full SAT course which goes over every single topic that you need to know for the SAT. And in that course, I walk you through hundreds of practice problems to really get you feeling confident with each topic. If you're interested in that, the link is in the description, and assuming that you've taken your 5-minute break, let's hop into the next 5 problems for this video. So we start with problem 16. This problem says, if x is greater than 3, which of the following is equivalent to this gigantic fraction? And I think, before we even talk about this gigantic fraction, where a lot of people will get confused is just with this inequality. Because I'm going to show you the solution to this problem. And it's not going to involve this inequality at all. So people are like, well, why is it even there? It confuses them. And the answer is, this inequality is just stopping the fraction from being undefined. It's stopping there from being a 0 in the denominator. If you look at this fraction here, you can't have a -3 for x. You cannot have a -2 for x. And so what this inequality does, I don't really know why they chose 3, but it just keeps it so x can't be -2 and it can't be 3. Because if x is greater than 3, it can't take either of those values. So yeah, basically you never have to worry about that inequality. Again, it just stops the denominator from being 0. So let's actually get into this problem here. We need to get this guy to look like one of these. And how we need to start doing that, if you want to clean up a just gross fraction inside a fraction, whatever, what you want to do is get a fraction in the numerator and a fraction in the denominator. Here we have 2 fractions in the denominator. We need to combine those into 1. And so let's start doing that. I'm going to take the 1 over x plus 2. I'm going to add that to the 1 over x plus 3. We won't worry that it's all below a 1. We'll take care of that later. But let's start simplifying this here, or not simplifying, but finding our common denominators, because that's how we're going to have to combine it. We need to multiply the 1 over x plus 2 by x plus 3 over x plus 3, because that's going to be our common denominator. We just need to multiply the two denominators together. So then this guy is going to get multiplied by an x plus 2 over x plus 2. So this numerator here is going to be an x plus 3. The denominator here, that's going to be the x plus 3 times x plus 2. You can multiply that out. You might even be able to see it's exactly this x squared plus 5x plus 6 that it's showing you in the answer choices. So the x times x gives you the x squared. 3 times x gives you 3x. 2 times x gives you 2x. And then 3 times 2 gives you 6. And just so, I don't want to keep writing out a bunch of different work here, I'm going to combine these already. This is a 5x. So that's our first fraction. Then the other one is going to be x plus 2 divided by the same x plus 3 times x plus 2. So it's going to again be x squared plus 5x plus 6. And so now you can combine these guys. The denominator stays the same. And the numerator, you add them together. So x plus 3 plus x plus 2, just combine like terms. X plus x is 2x. And then we have 3 plus 2, which is 5. And so your answer is choice A, right? Well, no. We have to remember that this entire thing is beneath a 1, right? We were just talking about the denominator part. We have to now worry about this entire thing as a whole. From all the work we've just done, we know that 1 over x plus 2 plus 1 over x plus 3 is the same thing as a 1 all over a 2x plus 5 over x squared plus 5x plus 6. And we know that because we just found that this is equal to this. That's all the work we just did up here. So now, if you want to get this thing into the denominator, because that's what you can do when you have a fraction in the numerator and a fraction in the denominator, what you need to do is bring this guy up to the numerator and flip it. The reason that you can do that, by the way, is the same exact thing. It's literally stay, change, flip, or keep, change, change, or whatever you learned in like middle school of how to divide two fractions. This is the same thing, because remember, like people get so disconnected from this. That fraction bar, that is division. You're dividing there. So this can be rewritten as a 1 divided by 2x plus 5 over x squared plus 5x plus 6. And if you rewrite the 1 as a 1 over 1, so it's a fraction, and you can do that because 1 divided by 1 is 1. If you rewrite it like that, then what you end up doing is keeping this fraction, you change the sign to multiplication, and you flip this guy. This is exactly why you can take something from the denominator, bring it up to the numerator, and flip it. It's the same thing. Okay? So hopefully you see that, and that means that this guy is the same thing as bring this up to the numerator and flip it. This guy goes to the numerator, so it ends up being x squared plus 5x plus 6, and then you have this guy in the denominator. So that's it. That's really what this entire thing reduces to, and that is choice B. So moving on to problem 17. This problem, it looks really gross, but really it's not as bad as you might think. It says the equation blank, I'm just going to say blank, is true for all values of x not equal to 2 over a. Again, why is it giving us this? It's because if you plugged in that x was 2 over a here, you would get a 0 in the denominator. So it's saying it's true for all of those values of x, that's not this, where a is a constant. What is the value of a? So for these types of problems, you might not know what to do at all here. But if we want to start making this look nicer, making this look not so horrible, you can see that we almost have common denominators here. We just need this negative 8x minus 3 to have an ax minus 2 as the denominator. So what we can do is take this negative 8x minus 3 and multiply it by an ax minus 2 over ax minus 2. That will give it the ax minus 2 in the denominator. And in the numerator, that's going to be a little grosser. We're going to have a negative 8x times ax. That'll be negative 8a, and then there's two x's, so it's x squared. Next, we'll do the negative 8x times negative 2. That will give us a positive 16x. We have a negative 3 times ax. We have a negative 3 times negative 2. And that's it. So now we have common denominators everywhere because this negative 8x minus 3 is this thing. I know it looks like we just messied this up even more, but we haven't, because Now that we have common denominators everywhere, the denominators go away. And you might be like, well, why do they go away? Well, there's a couple ways I can explain that. I think the easiest way to explain that, first off, if you have common denominators everywhere, you could just multiply them on both sides. So I would get ax minus 2. That cancels out here. The ax minus 2 would cancel out with the ax minus 2's in the denominator on the right-hand side. So that's a way that you could make the denominators go away. But I also want you to see it from this angle. So first off, I know that 2 over 5 plus 3 over 5 is equal to 5 over 5. Right? That's just basic addition of fractions. Now, I have common denominators everywhere here. And so, yeah, you can think about it as multiplying by 5 on both sides, and that gets rid of all the different denominators. But how you can also think about it is that when all of my denominators are the same, the numerators have to be the same. As in, 2 plus 3 needs to equal 5. And it does. That would make sense. 5 is equal to 5. That's how this works. So when the denominators are equal, the numerators have to be equal. So that means that this 24x squared plus 25x minus 47 needs to equal the numerator for this guy, which is this mess, which is negative 8x ax squared plus 16x minus 3ax plus 6, and then we have a minus 53. So these two things have to be equal if we have the same denominators. So we have that. That's great. We can combine a little bit of like terms here. That'll give us a negative 47, so we can write all of this again, but now this has a negative 47 in it. But yeah, that doesn't really help us much here. It doesn't help us at all. And actually, what are we even trying to do here? Because this just looks really gross. What are we doing? We're finding the value of a. And it's very easy to do that, actually. If these two things are equal, if they are equal, they have to be the same thing. That means that this thing needs to be a 24x squared plus 25x minus 47. Because these things are the same for, it's not just like one or two values of x. It's all values of x that are just not this. So, x equals 1, 2, 3, 4, 5, whatever. That all works, just not this one. And so if these are going to be the same for all values of x, the only parabola that can be equal to this is itself. That means that this negative 8a needs to be a 24. So that on this side, we also get a 24x squared. If you think about the x terms, we don't need to solve this problem. You can already see that a is negative 3. But the 25 here needs to be equal to 16 minus 3a. And you'll see that that works as well. That'll be our way of checking. But negative 8a, just divide this by negative 8 on both sides. You again see that a is negative 3. And that's all you need to do. So that's our answer here. But just going a little bit further, making sure that this is our answer. If you plug in an a equals negative 3 here, then this negative 8 times negative 3 is a 24. This combines to be a 25x once you plug in the a is negative 3, and then you get that negative 47 there, and that will make this thing equal to this. So that's how these problems work, and hopefully with that explanation, that makes sense to you, because I know a lot of people get tripped up with these types of problems, because honestly, did you ever learn these in high school? I don't know if I ever learned how to do a problem like this. So yeah, that the SAT kind of just throws that in there. Moving on to problem 18. This problem says the equation above gives the height h in feet of a ball t seconds after it is thrown straight up with an initial speed of v feet per second and from a height of k feet. Which of the following gives v in terms of h, t, and k? So all we're trying to do here is we're trying to solve for v. That's all this problem is asking for. And so to start solving for v with this equation, I'll write it out below here. H equals negative 16t squared plus vt plus k. If we want to start solving for v, we need to get all these terms that do not have v over on the other side. So what I'll start by doing is adding 16t squared on both sides. That'll get that guy over to the left-hand side. And then I'll subtract k on both sides. So now I'm going to end up getting that h plus 16t squared minus k is equal to, the only thing left on the right-hand side is the vt. And now all we have to do is divide t on both sides. Doing that, I'll switch the sides now, so I'll put v on the left-hand side. V is going to equal h over t plus well, now we're going to have a t cancel off, right? One of these t's is going to cancel off with this t. So we're going to be left with a 16t there. And then we have that minus k over t on the end. And we can simplify this a little bit more here. We can write this as, well, since we have two fractions here with common denominators, this can be written as h minus k divided by t plus 16t. And that right there is our answer. That's choice D. Now, somewhere where you might have gotten caught up here, when some people divide the t on both sides like this, what they'll do, and here's what I usually don't write it like this, what I'll usually write it as is like the h plus 16t squared minus k. I'll write that all over t. And that's the exact same thing as dividing each piece by t. And if you don't believe me, if you're having a hard time believing that, this is just a bunch of fractions with a common denominator. We can add and subtract all those together to get this. So it's the exact same thing. It's just, in this problem especially, it was easier to write it like this because then we were able to simplify a little bit and get something like one of our answers. So just a little thing to watch out for there. Moving on to problem 19, this problem says the table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? So what this problem is saying is, hey, we're going to get rid of this 24. It's an error. Which of these guys is going to be affected the most? And so let's think about it. Remember, we don't need to actually go and calculate how much the mean is going to be affected. Just get a decent idea for it. You got to think, these SAT problems, they're not supposed to take like 10 minutes to do, right? You don't have to be exact with it. This is multiple choice. So if you think that doing all this computation is going to take like 10 minutes, that probably tells you that you're thinking about this a little too hard. If we just think about the mean here, we're going to take away that 24. Yeah, that'll affect the average a little bit. Not a crazy amount. The median, take away that 24 and your center number is probably what, like a 12? If you take away that 24, now your center number might be like over here. That doesn't change the median at all, actually. And what about the range? Well, remember that the range is the largest number minus the smallest number. So the range here is 24 minus 8. And that's 16. After we take away that 24, the largest number is a 16. And so we get 16 minus 8 is the range. The range drops by 8. By 8 inches. That's huge. Is the mean going to drop by 8 inches? Is it going to change that much? No, there's no way the mean would drop by that much. And so the answer here is going to be C, the range. All right, moving on to the last problem for this fourth set of 5 problems. We have this problem right here. What are the solutions to this quadratic equation? So here's one thing I'm going to say right off the bat. Do not waste your time trying to factor this. There is a clear indication that you should use the quadratic formula here. And what's telling you to do that is the fact that all of these answer choices have radicals in them. They all have a square root. So, you're not going to be able to factor that and get a square root. So what you want to do is pull out the old quadratic formula. And honestly, before you go and start plugging in the A, B, and C, I wouldn't even go that far yet. What I would do is start off by simplifying this quadratic equation. And I'm really trying hard not to write slanted like this. This is annoying. like my entire thing is just rotated. All right. So what I would do, I see that these terms are all multiples of 3. And so I'm just going to divide by 3 on both sides. And remember, if I divide this entire thing by 3, it's the same thing as dividing each piece by 3. And so what that gives me is x squared plus 4x plus 2 equals 0. And these are going to be some much nicer numbers to plug in, because in this quadratic, a is equal to the number out in front of x squared. That's a 1 here, because you don't see a number there. B would be equal to 4, and then C would be equal to 2. And that's much nicer than having a 12 in there, which, just makes things a little grosser. And I should note too, these are going to have the exact same solutions. We haven't changed this equation at all, because we divided the exact same thing on both sides. That is what makes it not change. So let's actually plug into the quadratic formula here. I'll drag this guy this way. And we know that b is 4, so this is going to be a negative 4. We have the square root of a b squared, that's a 4 squared, that's going to be 16, minus a 4 times a, which is 1, times c, which is 2. And that's all going to be over 2 times a. A here is 1. Now let's simplify a little bit here. What we're going to do is write the negative 4 plus or minus. This is a square root of, this is a 16 minus, this is just an 8. 4 times 1 times 2 is 8. So you get a 16 minus 8, which is 8. And that's going to be divided by 2 times 1, which is 2. So we get this, and that doesn't match any of our answer choices here. So what do? Well, we're going to have to simplify this radical. But before we do that, there is something I want to note here, and that is that you can already see which of these answers it is without simplifying the radical in the first place. You just might not see that right away, so I'm going to fully solve it anyway. But you can see here that this first term, the one before the plus or minus, is going to be a negative 2. It's negative 4 divided by 2. And if you look at the answer choices C and D, they both have a negative 6, so they can't be right. And you can see if it's going to be A or B, just because B is the only one with the square root of 30, and there's no way you're pulling a square root of 30 out of this. You have a square root of 8. How are you just going to magically make that bigger? So B is not the answer either, and A would be right. So if you can see that right away, great. If you can't, here's how to simplify that square root of 8. So if we want to simplify a square root, what we need to do is take out the largest perfect square that we can out of this 8. And perfect squares are just all the numbers that you can square root and get something nice. So for instance, square root of all these numbers, you get 1, 2, 3, 4, 5. Perfect squares can also be variables, like x squared is a perfect square, because if you square root it, you get something nice, that just being x. And that's why when you have a difference of perfect squares, and you can factor it like this, these are two perfect squares and they are being subtracted. That's why they call it a difference of perfect squares. So that's just something I just figured I would add on there. But yeah, we're trying to take out the largest one of these numbers that we can out of 8. And of course that's going to be 4. Because we can divide an 8 up into a 4 and a 2. Because the square root of 4 times the square root of 2 would be the square root of 8. And the reason why we want to take out the largest perfect square is because then we can just, when we square root it, the square root of 4 is 2. And so the square root of 8 can be written as 2 times the square root of 2. If we write this all out, we're going to have a negative 4 divided by 2 plus or minus a 2 rad 2 divided by 2. And we can simplify that all at once to get negative 2 plus or minus, the 2's cancel, we get rad 2. And that was exactly the answer that we thought it was going to be. So that is going to do it for our fourth set of 5 problems for this video. So again, go take a break, just do something other than this video, come back with a clear head, and then we'll get into the next set of 5 problems, which is honestly, I think, quicker than this one. There's just like one problem that involves a little bit more work. So, assuming that you've taken that break, let's hop in to the next set of 5 problems, starting with problem 21. So, problem 21 says that the cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost C in dollars for each hours of phone use? So, what are we trying to find here? We're trying to find the cost C in dollars for H hours of phone use. So we're trying to find C in terms of H. And you can see all those equations there with C in terms of H. So what information does this problem give us? Well, it says in the first sentence that the cost is 20 cents per minute. So we can write that as an equation. We can write that C is equal to 20 cents per minute. We'll multiply it by M. That way, if we've been on call for 2 minutes, then this is 20 cents times 2. It's 40 cents, like we would expect it to be. The problem is, though, we don't want this in terms of M, we want it in terms of H. So we need an equation for M in terms of H. And no, the equation that you want is not 60M equals H. It is true that there is 60 minutes in 1 hour. That is a conversion factor. That is not an equation. Because as you can see here, if we plug in that 1 minute has passed, then it would be true that H is equal to 60. And 1 minute is not equal to 60 hours. So the conversion is not the same thing as the equation. Here's how to write the actual equation part. For the equation, we need to write the 60 on the other side. And that way, you can even check this. If we put the 60 on the other side, then plug in that 1 hour has passed. And it's true that 60 minutes have passed in 1 hour. So that's a way to double check that your equation is actually right. And if we have that, we can plug that in. Plug in that M is equal to 60H. And now you have your answer, which is choice A. And I don't know if this got you tripped up at all, if you tried this on your own first, but they are trying to bait you. They're trying to assume that you'll say that 60M is equal to H instead. And if you did that, then you would get one of these other answers. I think it would be, let's see, if you did that, you divide by 60 on each side, and so you would get this guy right here. And of course, that would be wrong. So you just got to watch out for that. Moving on to problem 22, this problem says if ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b is equal to 8, what are the 2 possible values for c? So let's write out what we know here. We know that ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14. And we know this is true for all values of x. This is another one of those correlating coefficient problems. It's the same as a problem that we tackled earlier. Where was it? I think it was the one right before this one. It's the same as this guy. Right, we were talking about how the 24 is equal to the negative 8a. It's the same kind of problem. So this is definitely going to be some good practice for you. So what we need to do is expand this guy. And if we do that, we multiply the ax times the bx. That gives us an a times b times x squared. Multiply the 7 by the ax next. And then the 2 times the bx. And then we can multiply the 2 by the 7 to end it off. It's equal to 14. And then we get 15x squared plus cx plus 14. And hopefully you can see here why I've actually multiplied this out. Right? We need to be able to compare the coefficients on this side with the coefficients on this side. And now that we've multiplied it out, we have those coefficients. We have the AB is the coefficient on x squared, and here it's 15. So we know if these two guys are the same for all values of x, then this side needs to be a 15x squared plus cx plus 14, just like this side is. So AB must be the same exact thing as 15. So we get a 15x squared here. So we have that. That's great. We also can now look at the x terms. We know that 7a plus 2b is equal to c. And that gets the x coefficients equal to each other. And of course, we know that 14 is equal to 14. That's true. That's good. And I think, that just tells us that, hey, we multiplied things out correctly. And that's nice. So we know that that is true. But what you might see here is that, well, there's no way we could solve for c at this point. The reason being, we have 3 variables, a, b, and c, and, well, only 2 equations. Remember, with a system of equations, well, we can solve for like x and y if we have 2 equations that have x and y's in them. But if we have 3 variables to solve for, we can't just get away with 2 equations. We need a 3rd equation. So where are we going to get that from? Well, the problem gives us another equation. It gives us that a plus b is equal to 8. And so if we combine all of these equations together, we can actually solve for c. So let's start solving this system of equations here. And we're not going to be able to solve for c right away, but we do have these nice 2 equations for a with a's and b's in them, so we can solve for one of those variables. I'll actually just solve for b in this first equation, so I'll subtract a on both sides. And so what I'll do is I will subtract a on both sides. Like that, I will get b is equal to 8 minus a. And if I've done that, then I can plug that in to ab equals 15. So I know that a times b is now an 8 minus a. We know that's equal to 15. So multiplying this out here, I get that 8a minus an a squared is equal to 15. And if this is a quadratic at this point, we can solve that. Subtract 8a on both sides, add a squared on both sides. And what I've done here is now I have 0 on the left-hand side. And on the other side, I have an a squared minus 8a plus 15. Awesome. So we can factor that. What are 2 numbers that add to be negative 8 and multiply to be 15? Well, negative 3 and negative 5. And so that means that a is equal to 3 and a is equal to 5. Those are the 2 possible values for a. Great. So if we have that, we can actually just go and solve for c now. And I'll show you how. Take this equation, the 7a plus 2b is equal to c. And what you can do is, you can just go and use these a's to solve for b, but you can do that as you plug in. If I plug in a 3 here, then we already know what the value of b is going to be. Since a plus b is equal to 8, I know that if a is equal to 3, like we just plugged in, then b would need to be 5. So you get 3 plus 5, which is 8. So this is one possible value of c. Now another one would be if we plug 5 in for a, because that's the other value it can take. And if a is 5, then b has to be 3, so they add to be 8. And so right there you go. So from here, you're going to get a 21 plus 10, that's 31. And from here, you get a 35 plus 6, that's going to be 41. And so that gives you the answer of choice D, which I'll go back up and show you in a second. So that is, honestly, that's the slow way to go about solving this, okay? I wanted to show you like the full way first because that's probably the default way that you'd solve this. And this problem is one of the longest problems that I have in this video, if not the longest. Okay, it does take a lot of effort, but there is a quicker way to solve this. And you might have noticed this while I was solving it, or you were just like, oh my God, there's so much, and you got overwhelmed, and you were like, all right, let's chill on this. So let me show you an easier way to go about solving this problem. Something I noticed while I was solving this was we could have found the values for A and B much easier. Because this is actually just the same thing that we do when we factor. We find two numbers that add to be 8, and we need those two numbers to multiply to be 15. So we could have found those numbers quick. We would have been, oh, well, first off, we could have A equal to 3 and B equal to 5. And then we could also have A equal to 5 and A equal to 3. Those two numbers would work in both of those equations. And remember, those are exactly the same values that we plugged down here. So you could have skipped all of this math right here if you would have realized that, but realizing that is the hard part. And the reason why I didn't just show you the short way and was done with it is because, well, you're not always going to see the short way. I mean, you're not going to see the short way to solve these problems 100% of the time. Really, no one is. Not me either. You think, like, with every single problem that I'm showing you, I always just immediately know the quickest way to solve these problems? No. No, not at all. So we're going to move on now to problem 23. And problem 23 says, in order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Half of the participants were randomly assigned to receive treatment X, and the other half did not receive treatment X. The resulting data showed that participants who received treatment X had significantly improved eyesight as compared to those who did not receive treatment X. Based on the design and results of the study, which of the following is an appropriate conclusion? Yeah, this is another one of those word problems where you read it and then just forget everything. So let's go back into this word problem and just figure out what we're actually talking about here. So yeah, I think honestly just even underlining as you go here is a good idea. But we're trying to draw a conclusion for this study here. And what did this study do? Well, it took a large population of people with poor eyesight. It took 300 people to be exact. Half of these people received treatment X. And the other half, they did not receive this treatment. And so the resulting data showed that those who received that treatment had significantly improved eyesight as compared to those who did not receive it. And so now we have to draw a conclusion based off of that. So choice A says treatment X is likely to improve the eyesight of people who have poor eyesight. And that's true. Yeah, so I would probably go with A right off the bat. Because we took the people that had poor eyesight, we gave half of them the treatment, and those who got the treatment showed significantly improved eyesight compared to those who did not. Choice B says it improves eyesight better than all other available treatments, and nowhere in the study did it talk about other treatments, so no. Choice C says treatment X will improve the eyesight of anyone who takes it. No, the study talked about people who had poor eyesight. And then choice D says treatment X will cause a substantial improvement in eyesight. Yet, maybe for people who have poor eyesight. These problems are so weird. The conclusion problems, they're essentially just completely common sense problems. You have to just make sure you're reading the word problem carefully. If you do read it and you understand it, then the answer choice is very easy to see from there. At least that's what I take away from these types of problems. All right, problem 24. This one's a little bit of a break here. It says if t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? So let's think about this here. We know that t squared minus 4 is equal to 0. That's a difference of perfect squares. So we can factor this as t minus 2 times t plus 2, and we can find the values of t. So from this handwriting is bugging me. T. Okay, cool. Nope, even worse. All right, anyways, t is equal to 2, and t is equal to negative 2. However, we can't just say either one of these for our answer. It says in the problem that t is greater than 0. And so since t is greater than 0, t is equal to negative 2 doesn't work. And so we're going to have to answer this with t is equal to 2. And so you're just going to, bubble in a 2 for your answer. So moving on to problem 25 here. This is the last problem for a set of 5, and this one's almost just as quick, honestly, as the last one. This problem says graphs of the function f and g are shown in the xy plane above. For which of the following values of x does f of x plus g of x equal 0? So, what does this mean again, this notation? I think a lot of people can get caught up with this. F of x is talking about the y value of the f graph. And the graph of f is this one right here. It points to it, this arrow right here. The graph of g is this one right here. So we're asking, well, when do the y values of each of these graphs cancel out? So when do they add to be 0? And if they add to be 0, they need to be on opposite sides of the x-axis. They need to be, so if one is at 4, the other one needs to be at -4. That way, when you add them together, you get 0. So where on the graph do you have that? Well, it's kind of sticking out right in front of you, right? Here, they're on the opposite sides of that x-axis. So here we have 1 at 2, 1's at -2. And so at this point, we're at, let's see. So this is where we're looking at. This would be x equals -2. Yeah, it's hard to see the y-axis here. So this is the y-axis. And therefore, this is -1. This would be -2. So, and I can write this out with notation just to get you feeling more comfortable with it. If we are looking at x equals -2, we know that f of -2, that's the y value for the f graph, that's -2. And the y value for the g graph, that's this one, at x equals -2, is a +2. And so these indeed equal 0 when you add them together. So remember what the problem's asking for. It's asking for the value of x where this occurs, and we already figured out that that happens at x equals -2. So the answer we circle is choice B. And so guys, the time has come. We're halfway done with this video at this point. We've done the first 25 problems, and now we have, it's all downhill from here. And I'm saying that for you, but I'm also saying that for me, because like now I only have to record 25 more problems. Like I'm just sitting here in my room. Anyways, so take your break here, just hey, reward yourself. Take a 10-minute break this time. And then let's get back in and finish this video up. So we are going to start with problem 26 here. This problem is pretty quick. It says the complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? So we're looking at where f of x is at its minimum. Remember what f of x actually means. It's talking about the y value of the graph that we're calling f. And that's this guy right here. We're calling this f. So we're asking, where is this y value at its minimum? Where is it the lowest? And that's happening right here. The answer is not -2, because that's not what this problem is asking for. The problem is asking for the value of x, where this happens, where it's at its minimum. And that value of x is going to be at -3. So don't get caught up there. You can see that they're baiting you for that -2. So that was pretty quick, and moving on to problem 27 here, this problem says, according to the system of equations above, what is the value of x? And we've done a couple problems at this point involving a system of equations, so if you're really getting comfortable with this, if this video is actually helping you, then you should be able to solve this problem, pretty quickly. You don't have to speed through it or anything, but you should be able to kind of get the hang of this. So let's look at this problem. How would we solve it? Well, I did show a couple ways to solve systems of equations using elimination method, so maybe it's time that I talk about substitution method. This is another way that people like, especially when they're first learning how to solve systems of equations, like I always went with substitution method. So what we can do here, if we're trying to solve for x, we can find a substitution for y. That way the y's cancel out when we substitute. So what we can do is take this equation here, this x plus y equals -9, and we can solve for y. And we can solve for y by subtracting x on both sides. So if we do that here, we get y is equal to a -9 minus x. I'm going to write that as a negative x minus 9, just because that looks more normal to me. And if I've done that, I can substitute that y in for the second equation. And doing that, I get x plus a 2 times y is now negative x minus 9. That's equal to negative 25. So I can distribute that 2 through. Distributing the 2 through to the negative x, I get negative 2x. Distributing that 2 through to the negative 9, I get negative 18. And that's equal to negative 25. Combining like terms here, I'm going to get a negative x. And then, honestly, I don't want this negative 18 on this side. So what I can do is add it over. So these like terms still combine to be a negative x, but now the 18 is gone, and this is all just equal to whatever negative 25 plus 18 is, which is negative 7. And how do I know that? Well, just think about this as 25 minus 18. That's 7, but the larger number here was negative, so we put a negative on it. Okay, just making sure we're all on the same page with that. So we can divide each side by negative 1 here, and that's going to give us the value of x. So x would equal 7. So 7 is going to be your answer for the second problem for this set of 5. So moving on to problem 28 here, we have that in the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between a and b must be true? So we're given the system of inequalities, and we're given that 0, 0 works for it. So if 0, 0 works here, let's plug it in and see what we get. If we plug in 0, 0 into the first inequality, plug in the 0 for y, and plug in the 0 for x. Well, negative 0, that doesn't make sense. So I'm just going to put a 0 there. And that's going to give me 0 is less than a. Now just do it for the second inequality. Y is greater than x plus b. If I do that, I'm going to get 0 is greater than 0 plus b. And simplifying that, 0 is greater than b. So now I have two things here. I have that 0 is less than a, and I have that 0 is greater than b. So how do I get a relationship here between a and b? What connects these two inequalities? Well, what connects them is the fact that they are both showing a relationship to 0. So if they both have a relationship to 0, then they have a relationship to each other. I'll show you what I mean. We know that 0 is greater than b. That's the second inequality here. But we also know that 0 is less than a. And how do we write that here? Well, we can write this inequality backwards. Because we can read inequalities backwards. We can write this, or we can read this as 0 is less than a. Or we can read this as a is greater than 0. So if we read it as a is greater than 0, then we can write it as a is greater than 0. So now, if a is greater than 0 and that's greater than b, well, a has to be greater than b then. Right? That it wouldn't work for a to be less than b because a is greater than 0, and 0 is a number that's already greater than b. And so here we get that a is greater than b, which is choice A. So that is our answer for problem 28, and now we can move on to problem 29. Problem 29, we're going to get into some geometry here. We have that two isosceles triangles are shown above. If 180 minus z is 2y and y is equal to 75, what is the value of x? So we know that y is 75. We also now have an equation to find z. Z is not also 75 because these are not vertical angles. They would be vertical angles if we had two lines that were intersecting. Then this angle would be equal to this angle, and this angle would be equal to this angle. But that's not what we have here, because this isn't just one line. This is two lines that are intersecting. They're different, right? You can see it's bent here. So that's not just a straight line. So we're going to have to use that equation to find z. We can do that very quick. So y is 75. We can plug that in. You guys like how I'm writing my z's? Isn't it cute? I'm writing little cursive z's. Nobody cares. All right, so this is 150. And then I can, what am I going to do here? Let's just subtract 180, I guess. I was thinking about doing something else, but no, I'm going to have the negative here. Anyways, negative z is equal to negative 30, and we can divide by negative 1 on both sides and get that z is equal to 30. So now that we've found z, we're getting closer to finding x now, and there's one more thing we have to realize because we have to make a connection here between z and x. And so what we need to realize is that this is an isosceles triangle. And what that means, since these two sides are the same length, it shows that right there with the two bars, that means that their corresponding angles are the same length. And these angles matter because this angle right here is supplementary to this angle, right? They're supplementary angles, which means that they add to be 180 degrees. So if we know this angle, we can find x. And that angle right there, let's just give it a name. We'll call it w. And now, this angle would be w2 because it's exactly the same. So all of these angles right here are going to add to be 180 degrees because, well, that's the interior angle sum of a triangle. So we have two w's there, plus z is equal to 180. So 2w plus z is equal to 180. And so we know z is 30, so I'll just substitute that in there. And we can subtract that on both sides. So you get that 2w is equal to 150. And dividing by 2 on both sides, that gives you that w is 75. And now that we have the value of w, which is this guy right here, we can find x. They are supplementary angles, so that means 180, that means they add to be 180, so I'll write that w plus x is equal to 180. And we know that w is 75, and we can subtract that on both sides, the 75. 180 minus 75 is 105, and that gives you the value of x. This is yellow? Yeah. Okay, now before we move on, I gotta note one thing about this problem. I'm showing you all the work right now. When you're on the SAT, you don't have to show all this if you're comfortable not showing it. For example, right here, I would have done all this in my head. I would have been if I would have seen that y is 75 right away, I can already tell that z is 30, because this is gonna be a 180 minus z equals 2 times 75, which is 150. You can already see here that z has to be 30. And you can do that little bit of work in your head, so you don't have to show everything I just showed. So you might be able to do that part in your head. There's also other parts of this problem that you could do a little bit quicker and not have to show as much work as I did. You don't need to write out w plus z. If you already see that's going to be a 2w, write the 2w. You know what I'm saying? So it all depends on the person. I'm showing out everything. You don't have to show out all of this if you can already do some of it in your head. With that being said, let's move on to the last problem for this set of 5. We'll move on to problem 30, and this one has to do with trig. So this problem says, in a right triangle, one angle measures x, where sine of x equals 4 over 5. What is cosine of 90 minus x? So this whole sine of x, cosine of 90 minus x thing, this is something that they love this on the SAT. They'll put this once per test. It's pretty much about that frequent. This isn't something that you really talk about much in class. It's just something that you kind of got to figure out when you're on the test. Sine of x is actually equal to cosine of 90 minus x. I want to prove that to you. So let's just think about some of these trig stuff. If you don't know your unit circle, it's fine. You'll get through this with me. If I make x equal to 30, I get sine of 30. I'm going to show you that's equal to cosine of 90 minus that. Because this is sine of 30. This is cosine of 60. And sine of 30 is 1/2. Cosine of 60 is also 1/2. So that works. And that's one example of where sine of x is equal to cosine of 90 minus x. You can also have sine of 45. That's equal to cosine of 45, or sorry, 90 minus 45. Because 90 minus 45 is 45. And we know that both of these are rad 2 over 2. So since you now know that sine of x is equal to cosine of 90 minus x, if you're given that sine of x is 4/5, then cosine of 90 minus x is also 4/5. And that's going to be your answer for this problem. And so that's going to do it for another set of 5 problems. And now we've done 30 problems so far in this video. We've got another 20 problems to go. And these 20 problems are pretty much all going to be calculator problems. In the beginning of this video, we did a lot of no calculator stuff with some calculator problems sprinkled in. But from here on out, it's going to be solely calculator problems. And so these problems, they're going to have some more geometry in it. There's going to be some graphs that we have to interpret and stuff like that. So you're going to be seeing a lot of different problem types from here on out. Okay, so assuming that you've taken your break, remember to do that. Assuming that you've taken your break and you're in a good headspace to get into these next set of 5 problems, let's get into this. So we are going to start off here with problem 31. And this problem says a food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? So we're asking for how many salads were sold, and we're given some information about salads earlier on. If we're trying to find salads, I'm going to give that a variable. I'm going to call that x. And the only reason why I'm trying to do this is because I don't see an obvious way to solve this problem in 5 seconds. Right? So I feel like we're going to have to go and work with some equations here. So starting off, I'm naming salads. So I also, just reading through this word problem, I do see some information about drinks right with salads. So I think it's only right that we give drinks its own variable as well. We'll call the number of drinks that we sell y. And now that we have that, we can actually start organizing the information that it gave us in this problem. First, we have that a food truck sells a salad for $6.50 each and drinks for $2 each. So we know that $6.50 for every salad plus $2, you can write as 2 with the decimal points and all that, or you could just write it as 2y. That's how I'm going to write it because I think it clears things up a little bit. I know that that's equal to the total amount that they sold that day, which is $836.50. Because this right here, the 650x, that gives me the amount that they sold from salads. The 2y, that gives me the amount that they earned from drinks. So then in total, if I add these two things together, I get the total amount that they made off of salads and drinks. So is there any other pieces of information in this problem? Well, yeah, because what about this 209? Well, that's how many salads and drinks they sold in that day. And that's actually good that we get that other piece of information. Because right here with this equation, we're not going to be able to solve for x. Remember, if we have 2 variables in an equation, we need 2 equations to be able to actually solve for one of those variables. So what we can do is say, well, okay, we know x plus y, the number of salads that we sold, plus the number of drinks that we sold, is equal to 209. And now from here, we can solve a system of equations. So you can solve this with elimination method. Personally, I'm going to solve this with substitution method here, and I'm going to start by solving for y. So I'm going to subtract x on both sides here. I'll solve for y in this equation, and then we'll plug that into the y in the other equation. So subtracting x on both sides here, I'm going to get that y is equal to you can write that as 209 minus x. I'll write that as negative x plus 209. And now we have y solved for. We can plug that into the top equation. Doing that, we're going to get 650x plus 2 times y is now negative x plus 209. And that's equal to $836.50. So now that we have that, we can do a little bit of distributing with that 2. 2 times negative x is negative 2x. And 2 times 209 is 418. And that's equal to $836.50. So we can combine like terms here, and also, at the same time, we want to get everything that doesn't have an x over to the other side. And so I'm going to do all of this at once, because I don't like writing that much. So I'm going to subtract that 418 to the other side. And I'm going to combine like terms. So on the left-hand side, since I don't have that 418 anymore, all I have left is the 650x minus 2x. That's going to be 450x. And I know that that is equal to 836.50 minus 418, which you can do in your calculator if you want. You might also see right away, though, that that's 418.50. So, it's up to you if you want to use your calculator for some of this. This is a calculator problem. But at this point, I'm going to divide each side by 450, and this I definitely am going to use my calculator for. But I'm kind of cheating because I already know what the answer is here, so I already know that if we divide these two in our calculator, we're going to get 93. And 93 is what? It's x. But what is x? X is the number of salads that were sold that day, and that's exactly what we're asking for here. And so we can safely say that the answer to this problem is choice B. So moving on to problem 32, this is the start of those geometry problems I was talking about. This problem says in triangle ABC, the measure of angle B is 90 degrees. BC is 16 and AC is 20. Triangle DEF is similar to triangle ABC. That's an important note right there, where vertices DEF correspond to vertices ABC respectively, and each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. That's another really important note right there. Then it asks us, what's the value of sine of f? Okay, so I know that probably seems really overwhelming. We were given a bunch of side lengths. We said, okay, these triangles are similar, and now we're asking for like trig stuff? All right, let's unpack this for a second. First off, I know that I have this right triangle here, triangle ABC. And it tells me right in the problem that this is a right triangle. B is the right angle. So now that we have that triangle, let's talk about the other triangle, triangle DEF. And we know that triangle is similar. That means it has all of the same angles, but its sides are 1/3 the length of that of this triangle, the triangle ABC. So what I'm going to do, I'm going to make the exact same triangle, but just a little bit smaller. A little bit bigger than that, honestly. I want you to be able to see it still. And so this is going to be DEF. So there you go. Great. Now, we know a couple things about these the sides of these triangles. We know that BC has a length of 16. We know that AC has a length of 20. And what we're trying to do is find sine of f. So we're trying to find sine of this angle here. And we know from SOHCAHTOA. Well, actually, that's probably a great place to start. In SOHCAHTOA, the SO part, that tells you about sine. Sine is opposite over hypotenuse. And, well, looking at the angle F here, the triangle DEF, what side is opposite to F? Well, it's DE. So this is the opposite side that we need. And where's the hypotenuse of triangle DEF? Well, the longest side is over here. It's this guy right here. So now we have the opposite side and the hypotenuse labeled. And so all we need to do is find the lengths of these sides. But how do we get there? Well, first off, it's pretty easy to find the hypotenuse of this side since we know that each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. So that means the hypotenuse isn't 20, it's 20 divided by 3. And if you don't see that right away, you're not sure where I got that from, just multiply 20 by 1/3, and that's equal to 20 divided by 3. So if we're on the same page there, then the only thing left to do is find the opposite side of triangle DEF, right? The opposite side of angle F, rather. And so for that, we need the length of side AB. We don't have that yet. We can find that using the Pythagorean theorem, since this is a right triangle. Or if you want to be a little bit quicker, if you know your Pythagorean triples, you know what the other side is. Because let me go through the Pythagorean triples real quick. So there's two main Pythagorean triples that I would say to memorize for the SAT. And honestly, the 3, 4, 5 triangle, that is the most common. That's what this one is. It's a 3, 4, 5. And you don't see it yet. I'll talk about that in a second. Another one to memorize is 5, 12, 13s. That's another one. And so these are just common triples that you can see. So for instance, if this side is 3 and this one's 4, you know that this one's 5. If you didn't know one of these sides, you could recognize, oh, well, the other side must be a 3 then, so we have a 3, 4, 5 triangle. So that's what Pythagorean triples are all about. Now, if you know these, you can do a lot of the Pythagorean stuff on the SAT in your head. And you might be like, though, okay, I can't draw the connection, though. How are you talking about 3, 4, 5 triangles, and you're saying that's going to help me here when our side lengths are like 16 and 20? Well, that's because all the multiples of your Pythagorean triples will also work. So if I just multiply all of these guys by 2, another Pythagorean triple is 6, 8, 10. Multiply these by 3, another Pythagorean triple is 9, 12, 15. And if you multiply by 4 here, you get the one that we have, which is a 12, 16, 20. So these are all Pythagorean triples. If you see this 3, 4, 5 ratio, which I kind of saw here, I saw that we had, the 4 and the 5 piece. So right now we need the 3 piece. We need the 12. So if you see that ratio, then great, you're skipping a little bit of Pythagorean theorem, and that does speed you up a little bit. If you don't see that, it's not the end of the world. Just calculate it using Pythagorean theorem, and you still are going to get the right answer. So if we know that side AB is of length 12, then we know what the length of the opposite side is. It would be this divided by 3. 12 divided by 3 is 4. And now that we have that, sine of f is easy to calculate. Sine of f is going to be your opposite side, which is 4, divided by your hypotenuse, which is 20 divided by 3. And remember how we do division of fractions. That's all this is. It's just division of fractions. When we want to divide two fractions, think about this as a 4 over 1 divided by 20 over 3. It's that stay, change, flip, keep, change, whatever you call it. All we're going to do is keep this one, change the sign to a multiplication, and flip this fraction. And all that equates to, you don't need to think about it like this every time. All you need to do is take this fraction that's in the denominator, bring it up to the numerator, and just flip it. That's all you have to do. So if we do that, we're going to get a 4 times, flip this fraction. It's going to be a 3 over 20. Notice how that's the exact same thing as the whole stay, change, flip, keep, change thing I was talking about earlier. So if you multiply this, 4 times 3 is 12, so you get 12 over 20. And if we keep going here, sine of f is equal to 12 over 20. We can simplify that. Just divide by 4 over 4. Right? Divide by I probably should write it like this. You're dividing 4 on top and bottom. So what you get is a 3 over 5. So that is sine of f right there. It's 3 over 5. And yeah, that's just our answer here. There's no multiple choices to circle. So moving on now to problem 33. This problem, we're given a graph here, and it says Michael swam 2,000 yards on each of 18 days. The scatter plot above shows his swim time for and corresponding heart rate after each swim. The line of best fit for the data is also shown. For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit. So I did take a little pause there. I was going to say, let's just find that already. But that swim that took 34 minutes, let's go find that on the graph. So swimming time is right on the x-axis. So we're looking at whatever point is right on this line. And I'll zoom in so you can see it a little bit better. We're talking about this point right here. That's the swim that took 34 minutes. And what are we asking about that swim? I'll keep that highlighted. We are asking how many beats per minute less than the rate predicted by the line of best fit. So beats per minute is right here. We're asking how much lower is it than the line of best fit? The line of best fit would have said that the beats per minute would be at 150. Well, what is it at right now? Look at your y-axis. Don't make a silly mistake. These increments are going up by 2s. So we're going like 142, 144, 146, 148, and we're at 148. So we are 2 lower than what the line of best fit would have suggested we would be at. And so B is going to be our answer here. So moving on to problem 34, here we have a table, and this problem says, the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what is the probability that the person belonged to Group Y? So, again, this is another word problem where you could literally read the whole thing and then just forget anything that you just read. So what we need to do is first off, identify the actual question. So let's read the whole last sentence because it's a little wordy. If a person is chosen at random from those who recalled at least one dream. So we are choosing a person at random from those who recalled at least one dream. We're not talking about anyone who didn't record any dreams. We're talking about just the people who recorded one or more dreams. And we're saying, well, what's the probability that if we pick a random person out of that group, that that person belonged to Group Y? So I think it's very easy to get messed up with what this probability is actually going to be. So I think it's best to just write it out. The probability, I'll call that P, is going to be, well, first off, what's the number of people that we're picking out of? We are picking out of the total number of people with one or more dream recalled. That's our denominator because that's the entire number of people that we're picking out of. And, well, what's the numerator? That's going to be the group that we're trying to look at here. We're talking about Group Y. And it's not going to be the total number of people in Group Y. No, that's not what we're talking about. We're saying, hey, we're picking out of the people who have one or more dream that is recorded. So the numerator is going to be just the number of people in Group Y with one or more dream recorded. Okay, so that's how this probability actually looks. And if you don't get this part, then you, of course, are not going to end up getting the answer. And I think a lot of people end up making silly mistakes on problems like this, so that's why I thought it'd be good to write this out. So let's find these numbers now. How many people in Group Y had one or more dream? Well, in Group Y, 11 recorded 1 to 4, and 68 recorded 5 or more. So the numerator is going to be 11 plus 68. And the denominator, that's the total number of people with one or more dream. That's going to be 39 plus 125. Okay, we're not going to count that 36 because they didn't record one or more dream. That's the people that we're picking out of. So again, the denominator is going to be 39 plus 125. And so the probability here is going to be 11 plus 68, that's 79, divided by 39 plus 125, that right there is 164. And I didn't actually do that in my head, I just looked at the answer because I knew it wasn't going to be 100. So I cheated, I guess. But yeah, so that right there is the answer for problem 34. And now moving on to the last problem for this set of 5. This problem says, of the following 4 types of savings account plans, which option would yield exponential growth of the money in the account? So this problem's asking which of these guys is demonstrating exponential growth. So I think a good place to start for this problem would be, well, okay, what's exponential growth? We probably should talk about that first. And well, the best way that I can describe it is, in this case, we're talking about money. Exponential growth is going to be when you are making money, like let's say every year, based off of how much money you currently have in your account. So let's say that you've had the money in for 3 years. Well, that account has grown by 8% every single year. And so now, let's say you put in $100, it's not going to be $100 anymore. Maybe it's like $120. So you're going to make 8% off of 120, not 100. So does that make sense? That's what exponential growth really is. You're gaining by a certain percentage every single year. So let's look at these answer choices here. Choice A says each successive year, 2% of the initial savings is added to the value of the account. Well, that's exactly what I just said that exponential growth was not, because we're not talking about a percentage of the initial savings. We want a percentage of how much money we have in the account right now. So choice A is not going to be it. Choice B says each successive year, 1.5% of the initial savings and $100 is added to the value of the account. Again, no, we're not talking about a percentage of the initial savings here. Okay, because if we throw in $100, okay, let's say that we make, 2% of the initial amount every year. Well, 2% of 100 is 2. And so that means that every year we'd be making $2. And the amount that we make won't increase. It's just going to be $2 every single time. Okay, and even if we add in an extra 100, then we'd be increasing by 102 every year. It's still the same exact amount. So choice C says, each successive year, 1% of the current value is added to the value of the account. So now we're taking a percentage of the current value, and that is exactly what exponential growth is. It's a percentage of the amount that we currently have in there. And choice D says each successive year, $100 is added to the value of the account. That's just like linear growth. Okay, that's another example of linear growth. We're just adding 100 every year. That's definitely not exponential. So the answer to this problem is definitely going to be choice C. So that does it for another set of 5 problems here. And so, I don't know, I think I've been recording for like 30 minutes here just on these like last 5 problems. So I assume that we've been going here for like maybe 20, 25 minutes. So at this point, definitely take another break, take 5 minutes, go stretch, get some water, do something. And then I'll be here when you get back. Let's go through another 5. I always got to make sure I'm giving you these reminders because I don't want you guys to just binge this. And if you're starting to binge this, you'll probably get to like problem 15, right? And then just be like for the rest of the time, so I want you to be refreshed after every set of 5. That's why I keep doing this. I feel like I'm justifying why I'm giving you guys breaks every single time that there's a break. I don't know. Anyways, let's move on to problem 36. So problem 36 says that the sum of 3 numbers is 855. One of the numbers, x, is 50% more than the sum of the other 2 numbers. What is the value of x? So first off, we have 3 numbers that add to be 855. Okay, that's just 3 numbers. I'm going to call that x, y, and z. And what we know is that, well, one of the numbers, this x here, it's 50% more than the sum of the other 2 numbers. So x is 50% more than y plus z. So how do we write that? How do we write this relationship between x and y plus z? Well, what we can do is say that x is 150% of y plus z. And I still have not given myself enough room here. Now, you might be very confused. Why did we put 150% there? Where does that come from? We're talking about 50% here. Why is it now 150? Let's think. So if I have a number w, okay, let's say I want 100% of w. That means I want all of it. 100% is just 1. And so This is the same thing as W. It's the same thing as 1 times W, which is W. From here, that's where I apply the increase. Because if I just said 50%, then I would be cutting this in half. That's not what's going on here. I'm increasing this value by 50%, which means I'm adding 50% to the one that's like technically out in front of the W. You get what I'm saying? So if I increase by 50%, now all of a sudden, we're not getting W, we're getting 1.5 times W. So that is why I'm putting 150% there. This is the increase of 50%. That's why you always see a 1 there. That's why that 1 always magically gets added. It's because we have to start from 100% and increase or decrease from there. So 150%, you can rewrite that in decimal form as 1.5. And now you actually have a substitution, because you know that if x, let's just erase the entire thing. If x is 1.5 times y plus z, then I can just replace that in here. I know that 1.5 times y plus z plus y plus z is equal to 855. See, I just plug that in for x because that's what this equation tells me to do. Okay, so at this point, I know you might be like, okay, we have so many y plus z's floating around here. This is really gross. I agree. There's a way that we can make this like look a little nicer. Okay, because we keep talking about the sum of these two numbers. We don't care what the value of y or z is. We care about what their sum is. So if we only care about the sum, then let's just call that a single variable. That's a gross z. Got to do better than that. There we go. Let y plus z equal, let's call it b. Because now things clean up, and I think it becomes a lot clearer to you how this actually works. And this is something you can do. Like, if it just, you see this y plus z repeating, all right, let's clean that up a little bit. So instead of 1.5 times y plus z, now we just have 1.5 times b. And then this right here, the y plus z, again, that's just b. And that's equal to 855. So adding these two together, a 1.5b plus b, that's going to be 2.5 times b. Because remember, this is just a 1. And so to find the value of the sum, just divide by 2.5 on each side. And you're going to get that b is equal to, actually, I don't know what you're going to get. Where's my calculator? Where's my calculator? I actually don't know where my calculator is. All right, let's cut. Guys, I found my calculator. It was just, my room's a mess, okay? I'm not even going to talk about it. So if we do 855 divided by 2.5, we get that b is 342. All right, great. Calculator part done. And no, it's not actually, because this is not our answer here. That's just the sum of the two numbers. We know that x is 1.5 times the sum of the two numbers, which remember we called b. So we have to multiply this by 1.5 still. X is 1.5 times the sum. And so it's 1.5 times 342. And that will be equal to, I don't know why I'm putting this in my calculator. I actually know what the answer is. This is going to be 513. There we go. So yeah, that's the answer for this problem, and I should note just before I move on, because I'm going to feel guilty if I don't mention it. There was one guy, when I made a TikTok video on this problem, who gave me just another way to think about this problem, and I actually think I like it a lot. So you might be able to see here that x is going to be 60% of 855. And how would you be able to see that? Well, because when you're talking about the sum of the numbers, that's 100% of the sum. Here, when we're talking about x, that's 150% of the sum. And you add those two things together as we went through the problem. And that's how we got the 2.5. Right? So what we want there, we don't want 2.5, we want 1.5. We want 60%. I don't know if you can see that, but if you divide like here, this is equal to 60%. So the value that we want x, it's 60% of that 855. So if we just multiplied that 855 by 3/5, or 60%, you would end up getting 513. So I don't know if you can see that. If not, no big deal. Just make sure you understand how we solved it here. And yeah, let's move on to the next problem. Moving on to problem 37 here. So in this problem, we are dealing with some angles. It says the angles shown above are acute and sine of A equals cosine of B. If A is equal to 4k minus 22 and B is equal to 6k minus 13, what is the value of k? So the big piece of information here that you might not know what to do with is that sine of A equals cosine of B. What does that mean for us here? Well, remember we talked about this earlier. I think it was problem 29, or no, it was problem 30. We talked about how sine of x is equal to cosine of 90 minus x. Okay, this is something that you need to know because, again, here's another example of how it can show up on the SAT. When you have sine equal to cosine, that means that the angle measures will add to be 90. Wow, losing my voice there. If you add these two angle measures together, you get 90. Okay, and that should actually kind of make sense to you if you know your trig a little bit. Because remember how like sine of 30, that's a half, and if you want to get another half, I mean that's cosine of 60. Right? These are both a half. And in this case, again, their angles add to be 90. So, I mean, if you want to think about it this way, you can, or just start writing some examples of where sine is equal to cosine. You're quickly going to see, like, for another example, sine of 45 is equal to cosine of 45. We could also have that sine of 0 is equal to cosine of 90. They're both 0. Right? In all of these examples, the two angles add to be 90 degrees. So if you can see it this way, that's great. If you can see it this way, that's great. But what that means for us is that A and B, they add to be 90 degrees. So since we know that A plus B is equal to 90, we can write this as 4k minus 22 plus a 6k minus 13 is equal to 90. Combining like terms here, we're going to get a 10k. Then we have a 22 and a 13. That's going to give us a 35, and it's negative. So this is a calculator problem here, just so you know. So we might need our calculator in a second here. I think all the problems at this point are calculator going forward. Yeah, 10k is equal to 125. And dividing by k on both sides, I guess you don't need a calculator for this. You're going to get that k is equal to 12.5. And that right there is choice C. So great, now that we have the answer to problem 37, we can move on to problem 38. So problem 38 says, which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoint 4/3, 5? So first off, let's talk about the equation of a circle, because if you don't know the equation of a circle, you're not going to know how to do this problem. So the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. The important pieces that we need to fill in here are this h, this k, and we need to fill in this r. The center of the circle is h comma k, and it has a radius of r. So, I mean, if you know that, the problem's really not that bad to figure out from here. We know what the center is. It's 0, 4. And so, writing out the equation here, we're going to get a x minus 0 squared plus a y. This is going to be a minus, right? We still have that minus there. That's not going to go away. We have k is 4. And that's going to be equal to r squared. So simplifying that a little bit, this is just an x squared. And then we have the y minus 4 squared. And we don't know the radius yet. So looking at this now and just comparing to our answer choices, we can see that it's not choices B or D because they have a y plus 4 there. And that's where they're trying to get you. They really do try to get you with remembering this minus sign. That minus sign is extremely important because, like, let's say our center was 0, negative 4 instead. A lot of people will still say it's y minus 4 squared, and that's just not true. You can think about it as always doing the opposite of the sign. So in this case, we'll get x squared plus, and then we'll have a y minus. K now is a negative 4. So we plug that in. That doesn't count for this minus. That minus is still there. K is negative 4. That puts in another negative, and now we get a positive. Right? When you see two negatives like that, you can just make them both positive. And so you get a y plus 4 squared out of that. So that's how we could possibly get a y plus 4 squared, would be if k was negative 4 instead of a positive 4. But here, it's a positive 4, so we got the y minus 4. So from here, we need to find our radius, but honestly, you might be able to look at the answers and already guess what the answer is going to be. The reason why is because a common mistake that a lot of people make is that they don't square the radius. What goes out here is not the radius, it's the radius squared. So I'm willing to bet you that this is the radius and this is the radius squared. So that the answer is definitely choice A. And this is a trap. So let's find out. We could find out, we know one of the endpoints of the circle, so we can use the distance formula. Because, I mean, just drawing a picture here, what they gave us the center of the circle and they gave us a point on the circle. So if we determine that distance, which we'll call D here, D is R. That's the radius of the circle. So actually I'll call it R. So the radius is going to be the square root of, remember that distance formula. This is going to be x minus, I don't know, you might call this x2 minus x1 squared. Maybe that's what you call it in class. It's the distance between the two x points squared plus the distance between the two y points squared. And you have to square root that entire thing. So the radius here is going to be, let's pick what we're going to call our second point and our first point. Let's call this our second point and this our first point. So for our x's, we're going to have a 4/3 minus 0. And then we're going to have a 5 minus 4. There we go. And so we can simplify that. R is going to be the square root of, this is going to be a 4/3 squared, which if you want to square a fraction, you just square the numerator and square the denominator. So it's going to be 16 over 9. Right, just 4 squared is 16, 3 squared is 9. And then this is a 1 squared, that's 1. So what we get under here is a 16 over 9 plus 1. You can write that 1 with, a common denominator. You can write it as 9 over 9. Just, multiply this by a 9 over 9. And you end up getting that the radius is 25 over 9. And, square root of 25 over 9. So that gives you the radius. If you square root that, you can, just as we could square something, square a fraction, by just squaring the numerator and squaring the denominator. If we want to square root a fraction, we can square root the numerator and square root the denominator. So this would be, the square root of 25 is 5, and the square root of 9 is 3. So it's equal to 5/3. But remember, I said this was a trap. What we want here is not the radius, we want the radius squared. And you don't even need to find the 5/3 in order to find the radius squared. For the radius squared, just square the square root and get rid of it. So if you square, that cancels out with the square root, you get 25 over 9 is your r squared. And that is what you're going to be using for the equation. So you get your final equation is x squared plus y minus 4 squared, remember that's what we had before, is equal to the r squared. And r squared is 25 over 9. So after all that, we figured out that the answer was exactly what you would have expected it to be. It's choice A. So that is the answer for problem 38. So moving on to problem 39, this problem says Mr. Cole has a beaker containing n milliliters of solution to distribute to the students in his chemistry class. If he gives each student 3 milliliters of solution, he will have 5 milliliters left over. In order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. How many students are in the class? So, aside from the fact that you read a word problem that you might have just forgotten everything about, there is a quick way to just solve this problem in your head. I will talk about that after I solve it the slower way, because I think just if I solve it the slow way and everybody can see that way, then it's going to make it very easy for you to do it in your head, to think about how you would have done it in your head. So let's talk about the, slower way first. So the question here that we're asking, that's the first thing we need to think about when we go through a word problem, is how many students are in the class. So we want to find that, so I'm going to give that a variable. We'll call it x. X is the number of students. And now that we have that written out, let's just start going through the information in this problem. First off, we're given that his beaker contains n milliliters. And it says if he gives each student 3 milliliters of solution, that means he will have given out 3 milliliters for every student, so that's 3x. Because if he has 2 students, he'll give out 6 milliliters. If he has 3 students, he'll give out 3 times 3 milliliters, which is 9. So 3x represents the total amount of solution that he gives out. And it says if he gives out that 3 milliliters of solution per student, he's going to have 5 milliliters left over. So that means that the amount that he has, the amount of solution that he has in total, is going to be the amount that he gives out plus the 5 that he has left over. And now that we have that, we can use that exact same method to make another equation for the next set of information. The next set of information says in order to give each student 4 milliliters of solution, so now he's giving out 4x milliliters because it's 4 for every student. In order for him to do that, he's going to need an additional 21 milliliters. So let's think about how we would actually write that in an equation. The total amount of solution that he has, he doesn't have enough to give 4 milliliters for every student. He doesn't have that much. He needs an additional 21 milliliters. So the total amount that he has isn't the 4x, it's 4x minus 21, because after he gives out that 4x, he still needs 21 to actually give everybody 4 milliliters. A big mistake that I could see people making here is actually doing plus 21. But that's not true. The total amount of milliliters, he doesn't even have 4x. So 4x cannot be equal to n. It's got to be something less than 4x. And it says here that he needs an additional 21 to do the 4x. So if we subtract 4x from, we subtract 21 from 4x, we'll get the amount that he currently has. So that's why it's minus 21 and not plus 21. But if you have that, it's very easy to solve for x here, which is what we want. We know that both of these things are equal to n. And if they're both equal to the same number, that means they are equal to each other. So from this, I got another email during class, during this YouTube video. That's great. All right, so we can set them equal to each other. And now we just get all our x's to one side. I'm going to get the x's to the right-hand side, and I'm going to get everything that doesn't have an x to the left-hand side. And you'll notice why I did it kind of opposite, right? We usually get all our x's to the left-hand side. But I noticed if I get my x's to the right-hand side, I'm going to have a 4x minus 3x. That's just x. So that makes my life a lot easier. I'm not going to have to deal with any negative garbage or anything like that. So then we get 5 plus 21 on the left-hand side. That's 26. So this tells us that he has 26 students. Okay, not going to make a rectangle for me? There we go. Thank you. All right, so with that, that's choice D. So that is a slower way to think about this problem, but you honestly could have thought about this a little bit quicker. It's not that hard to set up these equations, but there is a way you can think about it mentally. So think about it. He is giving out 3 milliliters of solution and still having 5 left over. And then he's giving out 1 more milliliter to every single student. And now he's lacking 21. So that means he not only used up the 5 that he had extra to give 1 out to every student, but he also now needs an extra 21. So in order to give that additional milliliter to every single student, he needed these 5 milliliters and he needs 21 more. And so just looking at that, you can see that he wanted to give out 26 extra milliliters. And if there's 1 milliliter for every student, that means he has 26 students. So that is a quicker way to think about this problem. Hopefully that makes sense, just me talking about it mentally. I know a lot of people, they like to see it rather than just me saying it. But hopefully now that I've actually shown you some of the work, maybe you can trace back what I said to the work and see how it's basically the same thing. So that is problem 39. Now moving on to problem 40. So this problem says the equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. Again, that sentence literally went from here to here. Okay. After approximately how many seconds will the ball hit the ground? So, again, looking at this question here, we are looking at after approximately how many seconds the ball hit the ground, and this is a parabola. This is it's a quadratic equation that forms a parabola. And I don't know if you ever had to solve these problems before where, you throw a ball up in the air, it essentially is a parabola because that's what happens in real life. You get a parabola. So from that, you can calculate where the ball landed. And that's exactly what we're really doing here. We're saying after how many seconds the ball hit the ground, the path of this ball is going to look something like this, right? It's a parabola. And so where it started and where it landed are the zeros of the parabola. So if we want to see after how many seconds the ball hit the ground, let's just calculate the distance between the zeros. And so how do we do that? Well, the quadratic itself is actually very easy to factor. So we want to set that h equal to 0 because that's what we're trying to find. This is the h-axis. This is the t-axis. And 0 is going to be equal to negative 4.9 t squared plus 25t. So since both of these have a t in them, we can bring a t out. We can factor it out and write this as t times negative 4.9t plus take a t away from here. All you're left with is a 25. And this t is really gross, so I'm going to replace it. So from here, there are two things that could happen to make this side equal 0. There's two things that could happen to make this equation right here true. First, t could equal 0. That's one solution. So this thing starts at t equals 0. That's initially when it's thrown, which kind of makes sense. And why would t equal 0? Because if t is 0 here, it doesn't matter whatever this thing is. 0 times anything is 0. So that would make the equation true. Now, what else would make the equation true is if this thing was 0. Because again, then you get 0 times some number, and that is 0. So let's set that thing equal to 0 and solve for t. Let's subtract 25 on each side, and then we'll divide by negative 4.9. So here comes the dividing step. And this is something you can do in your calculator, or you can just see that it's saying after approximately, you're trying to estimate here. You can see that this is about negative 25 divided by negative 5, which is 5. So you can probably already see that t is about 5. And that is choice D. Okay, so that does it for another 5 problems. Now we only have 10 problems left. These are all calculator problems from here. We've got 10 problems left, so go take your break, and then you're going to have problems 41 through 45 to get done. And while you're taking that break, I have a little proposition for you. I'm really trying to get this video out there to as many people as I can, and so if you could make a TikTok about this video and it gets, let's say, 25,000 likes, then I'll give you 3 hours of one-on-one tutoring for free. Just tag me in the video so I can see it. And speaking of TikTok, I'll probably go try to make a TikTok about this YouTube video tomorrow. That's when I plan on releasing this video. And yeah, you're kind of seeing like a future me right now. I've already recorded all 50 problems and I've edited them too. So like I've been editing for like 10 hours now. And so now I'm just recording a few clips that I just want to throw in the video. So I'm going to try to make a TikTok about this video tomorrow, and I'll try to get some extra traction to it because again, trying to help as many people as I possibly can. And so assuming that you've taken your 5-minute break, let's hop into the next 5 problems for this video. So we're going to start off here with problem 41. And this problem says that a grain silo is built from 2 right circular cones and a right circular cylinder with internal measurements represented by the figure above. Of the following, which is the closest to the volume of the grain silo in cubic feet? So we're trying to find the volume of this object here. And something you need to know about the SAT is that it actually gives you the formulas for all of these things that you need to find the volume of. So it's got a formula sheet at the front of the booklet, and if you look at that, you can see that the volume of a cone is 1/3 pi r squared h, and the volume of a cylinder is pi r squared h. And this one should make sense to you. Like, the volume of a cylinder makes perfect sense because the area of a circle, okay, that's not a circle. The area of a circle is pi r squared, and so when you extend it into the 3rd dimension, the volume will be the area of the circle times the height at which you extended it into the 3rd dimension. Anyways, I'm kind of nerding out here. Let's actually solve the problem. So the volume here is going to be the volume of 2 cones, because as you can see here, we have 2 identical cones. We have a cone here and a cone here. So the volume is going to be 2 times the volume of a cone, which is 1/3 pi r squared h. And then we're going to add on the volume of the cylinder here, which is pi r squared h. And just doing that here, we're not going to combine all this notation here because remember, these are different variables here. This r and h is not the same as the other r and h. And I'll get through that confusion as I go through here. But the volume here, we can multiply the 2 and the 1/3. That's going to give us a 2/3. We'll have a pi times the radius of the cones is 5 feet. So we'll write a 5 there. That's being squared. The height of the cones is 5 feet. So that's going to be your h. And then you have plus pi times r squared h for the cylinder now. In the cylinder, it has the same radius, actually, so we're going to keep that with 5. And then we'll multiply by the height. The height of the cylinder is 10. And so that means that the volume of this entire object, we can simplify this a little bit, honestly, if you want to. Before you put it in your calculator, it's going to be 2/3 pi. This is 3 5s here. So that's going to be 5 times 5 is 25, times another 5 is 125. So this is going to be 2/3 pi times 125. And then this is plus, this is a 25 times 10, which is 250. So now it might make it a little bit quicker for you to put it in your calculator. It's less thumb work. That's why I like to simplify as much as possible. To be honest, for me, I would simplify even more than this before plugging into my calculator. But I'm a little weird. We'll do the 125 times 2/3 first. And so that is going to give us, if you put that into a fraction, this will be 250/3 pi. Actually, I could have just told you that anyway. And then you're adding on 250 pi here. Now we'll go and add these together. So if you do that, multiply your answer by pi, fiddling on the calculator here, you're going to get a volume of 1047.19, which rounds up to a 0.2. And the units on that would be feet cubed. So that is the first problem done of this next set of 5. So that's choice D. So moving on to problem 42, this problem says that Katerina is a botanist studying the production of pears by 2 types of pear trees. She noticed that type A trees produced 20% more pears than type B trees did. Based on Katerina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce? So with this problem, you might be able to do it in your head, honestly, and I can talk about how to do it in your head after I explain, I guess, more of the longer, more algebraic way of doing it. Like, I'll show out all the algebra. But what we're going to need to start off with here is we're going to need 2 variables. We need one to represent the pairs in type A trees, and we need one to represent the number of pairs in type B trees. So I'm going to do P sub A for the pairs in type A trees. You could honestly just put an A there and you'll know what you're talking about. So I'll say number of pairs in type A trees. And then P sub B would be the number of pairs in type B trees. Cool. So if we have that, I mean, look, it even tells us that type A trees are producing 20% more than type B trees did. So how do we write that? Well, there's going to be some equation here between PA and PB. We just need to know where to put that 20% increase. So type A trees are the ones that are producing 20% more. And so that means that this one is 20% greater than PB. So for these two things to be equal, you need to raise the smaller one by 20%. How do you raise it by 20%? Well, you're not going to multiply it by 20% like this, because then you're going to literally end up dividing this thing by 5. If you want to increase it by 20%, you add it to 100%. Right? Because 100%, we talked about this in a problem before, 100% of the pairs in type B trees is going to be all of the pairs in type B trees. What we're doing is we're trying to increase 20% from there. So we are not multiplying this by 20%, we're multiplying by 120%. That's the 20% increase. We need to start with all of the pairs, and then we increase 20% from there. So hopefully that makes sense. Now, if you know that, then, this problem gets really easy from here. Because this is a 1.2, and then we know that type A trees produced 144 pairs, so we can plug that in and then solve for the pairs in type B trees. Just divide by 1.2 on both sides. Doing that, we're going to get that the number of pairs in type B trees are 144 divided by 1.2, that's 120. And that's a blue. So that is choice B. So you can think about this in your head, honestly. You don't need to go through the whole equation thing. And look, I'm writing this part just so you understand where these variables are coming from. When you go through and do this, you're not going to be writing that down. You're going to be, you already know because you created those variables, so you know exactly what they are. And so unless it really helps you, you don't have to write that down. You can get to this equation really quick. And honestly, you might even be able to do that in your head. You're like, oh, well, type A produces 20% more than type B. That means that if I multiply type B by 1.2 by 120%, that'll get me to type A. So if I have to multiply this guy to get to type A, if I have to multiply it by 1.2, then if I know type A, I would need to divide that by 1.2, and that'll give me the number of pairs that type B trees produced. And that's exactly what we did here. We divided the number of pairs in type A trees by 1.2. So that would be my thought process of doing this in my head, and that's how I would pretty much do it. Okay, so hopefully that all makes sense. So moving on to problem 43 now. This problem says in the xy plane, the line determined by the points 2, k and k, 32 passes through the origin. Which of the following could be the value of k? Okay, so for this problem here, we're given a few points. We're given 2, k. We're given k, 32. We're trying to find the value of k though. And just with this information, I don't see how we're going to be able to do that. We need some other kind of information, because just the fact that it's a line, it's got these 2 points on the line, yeah, you might be like, oh, we have 2 points, we can find the slope. But what would the slope do for us here? If we found the slope with these two, we would get, what, a 32 minus k over k minus 2? That doesn't help find the value of k. We don't know what this slope is equal to. So we've got to have some other bit of information here that we just haven't gotten out of this word problem yet. And we do. If you look here, it says that the line passes through the origin as well. And that means that we have another point. And now we can do that slope thing that we were thinking about before. But of course, you weren't thinking about the slope thing. I was thinking about the slope thing and just assuming that maybe you would think of it eventually. So why should you be thinking of the slope? Why is that something that I would have thought of? Well, because for this problem, if we're given just multiple points in general on a line, the slope is just something that should be crossing through your mind. Oh, that's something that we can find. And if we have 3 points like this on the same line, well, think about it. We can find the slope between these two, and that's going to be the exact same as the slope between these two. It's got to be. They're on the same line. The slope can't be different. You can't have like a slope of 2 on one part of the line and then a slope of 5 on another part of the line. That's not how that works. The slope has to be the same. So we can set up an equation with the slope of, one of the slopes that we calculate, that's got to be equal to another slope, and maybe that's how we can solve for k. So that was my whole thought process with this. That is my whole thought process with this. So let's start off finding these slopes here. I'm going to start off by finding the slope between these 2 points. Remember, just in case this wasn't clear, the slope is y2 minus y1 over x2 minus x1. That's how you find the slope between 2 points on a line. And if we're using these 2 points, and I'm going to call this one the second point, so it goes first here, I'll have 32, and the x-coordinate would be k. And then I'm going to have minus minus. These are both zeros, so that actually makes my life really easy. I know that the slope is 32 over k. That's why I chose the origin point. I didn't want to choose both of these because that's going to be like really gross. Like I even showed you what it would be before. It's not fun. So that's one of the slopes. Let's calculate another. Again, it's the same formula. Let's instead this time use the 2 comma k and the 0 comma 0. I'll make this guy go first again, so it's going to be 2 minus 0. Sorry, not 2 minus 0, k minus 0. Because k is the y-coordinate. So we'll have k minus 0 all over a 2 minus 0. Because x-coordinate here, x-coordinate here. That's going to give me a k over 2. And now remember what we were talking about. These 2 slopes, they are of the same line. Lines aren't going to have different slopes like that. If we're talking about one line, then the slope is k over 2, and it's also 32 over k. That means that k over 2 is equal to 32 over k. And so what we can do to solve for that, just cross multiply. We get the k squared is 64. Right, we have a k times k, that's where I got the k squared from, and 32 times 2 gives me the 64. From here I square root both sides, and I get that k is equal to a plus or minus 8. So, there we go. That gives me the value of k. Now, from here, I do want to note the answer doesn't seem to be here. We don't have a plus or minus 8. But read the question again. It says, which of the following could be the value of k? It's not saying what are all the possible values of k. It's just asking for one of the possible values. And we have one illustrated right there. We could have a positive 8 be the value of k. And so C works. So moving on to problem 44 now. This problem is involving a system of inequalities. It says if the system of inequalities y is greater than or equal to 2x plus 1 and y is greater than 1/2 x minus 1 is graphed in the xy plane above, which quadrant contains no solutions to the system? You guys hear my dog barking? Yeah. See, I'm almost done with this video. I'm on my last leg here. We have 6 more problems to do, and my dog has to bark. All right, so hopefully he'll stop. If he doesn't, I'm just going to have to cut the video. But let's start setting these inequalities here. Okay, we have, first off, y is greater than or equal to 2x plus 1. And so if I just graph that here, 2x plus 1, it's going to look about like, give it a positive y-intercept there because it's got a positive y-intercept of 1. It's, relatively steep. It's got a slope of 2. And we know that we have to shade for these inequalities, right? That's part of it. We are talking about all of the y's that are greater than or equal to 2x plus 1. So not just all the y's that are equal to 2x plus 1. All the y's that are equal to 2x plus 1 is right here. But let's say that we're talking about like x equals 2. we're not just talking about this y value here. We're talking about all the y values above it too. And that goes the same for any x value here. So that's why we get a shading. Hopefully that makes a little bit of sense. We're going to be shading all the y's that are greater than this line. And now you actually might see an issue here. Look at what quadrant doesn't have any shading. Quadrant 4. And when we are asking for the solution to a system of inequalities, we are asking for where the shadings intersect. And the shadings can't intersect if there's no shading in quadrant 4 to begin with for one of these inequalities. So that means that quadrant 4 is going to be our answer here. But we know that there's definitely no solutions in quadrant 4. So we already know that that's the answer. However, if you didn't see that yet, let's go ahead and graph this next one. Now, this is something I don't really think you need to care about for the SAT, to be honest. But if y is greater than, it's not a greater than or equal to. And that goes the same for less than. If it's a less than and not a less than or equal to, you draw that with a dotted line. I don't know if you remember that. So I'm going to draw this one with a dotted line because that means that we're not talking about where y is equal to 1/2 x minus 1. So the dotted line doesn't count. Here, this solid line, it does count because we are talking about y's that are equal to 2x plus 1. And we're also talking about y's that are greater than 2x plus 1. But here we're only talking about y's that are greater than 1/2 x minus 1. So it's a little bit different. So again, we're going to give it a negative. It's got a y-intercept down here now. It's negative. And it's going to be at more of a shallow slope because it's 1/2. So it's going to only rise 1 for every 2 that we go over. So it's going to look something like this, right? I'm not drawing these exact, but now we can shade. And you can clearly see now, this actually worked really well. You can see exactly where the intersection's happening. You see some intersection in quadrant 1 right here. You see some intersection in quadrant 2. You see some intersection at the bottom, or at the top rather, of quadrant 3. But there's no intersection in quadrant 4. In quadrant 4, we only have one little bit of shading. We don't have the shading from the solid line. And so that further says that, oh yeah, quadrant 4 is definitely the answer here. All right, moving on to the last problem for this set of 5, and then we're on to our last set of 5 for this entire video, which is awesome. All right, I'm excited too. All right, so this problem says, in planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. So first off, I mean, you see this decrease by 10% every 20 years. You might look at your answers too. We're going to be making an exponential function here. That's exactly what we're going to be doing. And so you might already be thinking, oh, well, I know what the form for an exponential function is. We'll talk about that later. Okay, but so we should probably start underlining this type of information. If the present population of the city is 5,000, so that's your starting population. I want to get nice underlines for all of this. There we go. So if the present population of the city is 50,000, which of the following expressions represents the engineer's estimate of the population of the city t years from now? So we are trying to find P. We're trying to find the population of the city after t years. And to do that, we need to use the formula that we have for exponential functions. It's P equals P0 times 1 plus R to the nt power. And you might be like, oh my God, I have no idea what any of that means. Don't worry, I will define it for you. So P is going to be the population at time t, at some time t. So you plug in 2 years. Okay, well, P is going to be the population at 2 years. So that's what P is. P0 is your initial population. And actually a little fun fact for you, I don't know if you know this, I didn't know this when I was in high school. The reason why we write it as P sub 0, it's an abbreviation. It's like a shorthand for writing P at t equals 0. It's the population at your starting time. So, if you start writing this in a more compact way, you can say P sub t equals 0 to say, oh, that's your population at t equals 0. And that got shortened to P sub 0. So that's where that all comes from. I don't know. I think that's kind of cool. Maybe you don't even care. But, I mean, I need to entertain myself, guys. I've been doing this for like hours. So R is going to be your rate, and N is your number of compounds. This is something we need to go over a lot because everybody gets confused at that point. But I think something I need to touch on before we even start talking about the other stuff, just first off, when I'm naming N, it's the number of compounds, in this case, per year. But it's whatever units of time you're talking about. So like here we're talking about years. So N is the number of compounds per year. If we were talking about like hours instead, then N would be the number of compounds per hour. It depends on the units of time. Okay, so that's just something to especially review before you go into the SAT, because I know most people, they just get confused with that point. And so T is going to be time. But that's it. So now let's just start naming the information that we've been given here. First off, we were given that our initial population is 50,000. We were given this 10% every 20 years. Okay, the rate here, we are losing 10%. So that's going to be negative 10% or negative 0.1. Okay, it's got to be negative because we're decreasing 10%. I should probably underline the decrease part too. And I'll talk about the N in a second, like I said. So if we just start making this function here, P is going to be 50,000 times, that's the P0 part, we have 1 plus R. R is negative 0.1. People get lost with this because they will say, oh, well, we're decreasing by 10%, so there needs to be a 0.1 that goes here. But that actually decreases by 90% because that would make the R negative 0.9. And think about it, after every certain amount of time, you'd be multiplying by 0.1. That would be taking 10% of this 50,000. And that is a decrease of 90%. So hopefully, you can think about it that way. But at least we have this part figured out now, so we know that P is 50,000 times a 0.9. And so that already narrows down our choices quite a bit. Yeah, okay, I did that right. So now we need to see if there's going to be a 20t or a t over 20 in the exponent. This is where everybody starts getting confused. If we're talking about the number of compounds per year, it's the number of times per year that we're multiplying by 0.9. It's the number of times per year that we're decreasing by 10%. And we're not doing that a certain amount of time every year. It's actually one time every 20 years. So if we did 20 times t, that would be 20 times every year. We're doing once every 20 years, so it's not 20 times t, it's 1 over 20 times t. But yeah, that is me just trying to explain every single aspect about exponential functions, and that brings us to our answer of choice D. So that does it for, I guess that's our 9th set of 5 problems for this video. So take your final break. Seriously, do it. Okay, because I know you're like, oh, let me just jump into this next 5. Take a break, and then you'll be able to just cruise through these next 5. Okay? So assuming that you've taken your break, let's hop into this last set of 5 problems for this video. We start with problem 46, and this problem gives us a parabola, and it says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? That paragraph was one sentence. Okay, so anyways, what are we trying to do here? We're trying to find what equation will allow us to see the vertex. This problem, you don't need to actually complete the square at all. Because remember, when we want to find the vertex of a quadratic or of our parabola, we complete the square. And you don't need to do that here. Because it's just saying which of these equations will show you the vertex immediately. And that's choice D. Because that's the only one here that's in vertex form. Remember, vertex form is y equals a times x minus h squared plus k. And your vertex ends up being that h comma k. And I really want to go over this whole thing one more time just to make sure that you don't mess up with this, because on the SAT, you might have to identify the vertex. So it might not be this easy where you're just like, oh, well, which one's in vertex form? There could be SAT problems where you need to identify the vertex. There also could be SAT problems where you need to complete the square. And if you need to complete the square, if you want to review that, because I don't think we did that actually in all 50 of these problems, if you want to review completing the square, I have a full YouTube video on completing the square. I'll put that thumbnail right up here somewhere. But if you need to identify the vertex, let's talk about that. So everybody messes up at this x minus h squared. For the same reason that people mess up, we talked about this before in problem 38. It's the same reason that people mess up with the equation of a circle. Because again, you have the x minus h squared, and in addition to that, you also have a y minus k squared. In both of those, you do the opposite. You do the exact same thing for the h in problem 46, where we have vertex form. So, for example, what is the vertex here for the x minus 1 squared minus 16? Well, we can definitely see the k, that's negative 16. But what's the h? Well, yeah, you might see a negative 1 here, but h is 1. We do the opposite. Why do we do the opposite? Well, I can show you. Oh, and actually, just so you know then, the vertex would be negative 1, or sorry, it'd be 1 comma negative 16. But yeah, let me show you why we do the opposite again, just to make sure, especially if you ended up skipping that circle problem, now you can see it. First off, a is 1. You can see that there's no number out here in front of the x factor there. And that, a, it doesn't matter what number is out there. It's not going to change your vertex, because your vertex is based off of the h and the k, not the a. So what number do we need to put here? What number do we need to plug in for h in order for us to have an x minus 1? The minus sign is already there. It's not part of the h. And so if we want to have an x minus 1, all we need to do is plug in an h of positive 1. And then for k, well, we want a negative 16. We just plug in negative 16 for k. So that's where we get the 1 comma negative 16 from. Because we're not talking about this minus sign. It's not part of h. And just to make sure you really got this, let's say we wanted an x plus 1 squared in here. What would h have to be? Well, it would have to be negative 1. We do the opposite, and you can even see that if I just pull this apart here. If h was negative 1, then we would get an x plus 1 squared. So hopefully that whole thing makes sense to you, and that's some good review of vertex form. So on to problem 47. This problem says Wyatt can husk at least 12 dozen ears of corn per hour, and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? So we are asking for what here? We're asking for the time in hours that it would take Wyatt to husk 72 dozen ears of corn. So let's let t equal time, just to make sure we're all on the same page here. And the dozens of ears of corn that he has husked, we'll call that c for corn. And now, well, he needs to husk 72 ears of corn. I love that word, husk. I actually don't even know what that means, and I grew up on a farm, so that's pretty bad. But he can husk 12 dozen ears of corn per hour at the lowest. So at the lowest, the amount of corn that he husks is 12 times t, because after 1 hour, he would have husked 12 ears of corn. So you'd get 12 times 1, and that's 12. After 2 hours, it would be 24 dozen ears of corn, and so on and so forth. So that's the minimum. Now, for the maximum amount of corn that Wyatt could husk, we would then have c equals 18 times t. And if he needs to husk 72 ears of corn, then we just plug in the 72 for c. All right, so now divide 12 on both sides, and you can see that the minimum amount of corn that Wyatt would be husking in, I can't do that with a straight face anymore. This would be 6. So this is at his minimum pace, it would take him 6 hours. But at his fastest pace, it would take, 72 divided by 8 is 4. You don't need to do that in your head. There's a calculator for this. So that's at his fastest pace. And so what's the answer for this problem? We have that t equals 4 and t equals 6. Well, it's asking for what's one possible amount of time in hours that it would take him. And so there's actually a couple different answers that you could put here. So you could put anything between 4 and 6, because this is the quickest he could do it, this is the longest he would do it. So actually, if you put anything in between 4 and 6, that will work. So, for instance, I'd put 6 into the little Scantron thing, and I would be right. If I put 4 in there, I would be right as well. If I put 5 in there, I would be right. So, that's how that one works. All right, moving on to problem 48 here. Here we have in a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. So this is a central angle. That means that it connects with the center of the circle. I'm going to assume that that's about where the center is. Probably going to be a little bit down there. Yeah, maybe right. There we go. Okay. So we have a little central angle here, AOB. And now we know the angle measure is 5 pi over 4. The area of the sector formed by central angle AOB is what fraction of the area of the circle? So we're asking, okay, we're saying the area that's formed by this central angle. So this is the area we're talking about. I'm going to switch my highlighter color because this is green section. So this area here is what fraction of the area of the entire circle? So to know this, you need to know a very important thing about circles. Okay, there's a lot of different proportionalities when talking about circles, and I'm going to name everything that you need to know. So this is the proportion that you need to know about circles. I know it seems like a lot, like there's a lot going on here, but once I explain it to you, it's not going to be like, oh wow, that's so new, I would have never thought of that. It's going to be like, oh yeah, that makes sense. And if you know how to solve this problem already, it would have been like, oh yeah, that's how I would have solved it. So let's talk about this here. This equation is talking about the fractional area that's equal to the fractional angle, and that's equal to the fractional arc length. And that totally does not clear anything up for you. So I'll actually draw you a picture and show you exactly what that means in this context. So with the circle I've just drawn out here, I drew a right angle. That's my central angle here for this circle. And in this case, all of these fractions are 1/4. Because I have traced out 1/4 of the entire circle. For instance, the sector area. If I say that this area right here is 4, then what's the area of the entire circle? Well, the area of the entire circle would be 16. It'd be 4 times that because, again, I've traced out 1/4 of the entire circle. And so if you take the area here and you divide it by the area of the entire circle, which I said was 16, you'll get exactly that 1/4. Now, what about the central angle here? Well, for the central angle divided by 360 part, that's talking about how much angle you've traced out of the angle of the entire circle. Here, we've taken up 1/4 of the angle of an entire circle. And I'll show you that too. This is 90 degrees. The angle of an entire circle is 360. So again, that's 1/4. It's the same ratio. And lastly, for arc length and circumference, if I tell you that the arc right here measures, let's say, 6, what's the circumference of this entire circle? Well, there's 4 of these arcs on that circle, so it'd be 6 times 4, which is 24. And so let's divide that. The arc length here divided by the entire circumference, which we just talked about was 24, that again is 1/4. And so now that we've talked about this proportion extensively, we've talked about all the different moving parts, we can actually use that to help solve our problem here. And we're not going to use the arc length or circumference part because it just doesn't mention it in this problem, but some problems will. Here, though, we do talk about area, we do talk about angle, that's what we're going to be using. So again, this problem gives us that the angle measure here is 5 pi over 4. It says that the area of this sector, right here, formed by that central angle is what fraction of the area of the circle. So we're asking for the fractional area. That's exactly what I've just circled here. The sector area, the area of the little sector divided by the area of the entire circle. That's exactly what this is in math terms. And we know that that's going to be the exact same as the fractional angle, the amount of angle that we've covered out of the entire circle. It's the same ratio. So, well, let's do this here. The central angle is 5 pi over 4. Let's divide that by the angle of an entire circle, which is 2 pi. That's going to give us the fractional area. Now, to divide these two fractions, just think about it as 2 pi over 1, then we have two fractions. All you got to do, bring this 2 pi over 1 up to the numerator and flip it. We've talked about that a couple times in this video. And so you're going to get 5 pi over 4 times a 1 over 2 pi. So the pi's cancel. You get a 5 over 4 times 2, which is 8. And so we've traced out 5/8 of the entire circle. So, moving on to problem 49. This problem says that a dairy farmer uses a storage silo that is in the shape of a right circular cylinder above. If the volume of the silo is 72 pi cubic yards, what's the diameter of the base of the cylinder in yards? So, first off, big thing here, we're asking for the diameter. That is extremely important. And so we're not looking for the radius, because the radius is what we use for the volume. Speaking of which, if you want to figure out the volume for a cylinder, it's in the formula sheet that the SAT gives you. Okay, right at the front it should be, I think. Something like that. But the formula will be pi r squared h. And you can remember that, some of you probably do. It's just the area of the circle, which is the base of the cylinder, times the height of the cylinder, because you have to bring it into 3 dimensions. So it's not only the area here, but it's times that h. So that's how I remember it. All right, so if we know that, we know the volume is 72 pi. That's going to be equal to pi times the radius is what here? Well, we don't know. That's what we're trying to find. The height, though, we do know. That's 8. And we don't need to really worry about the units here. This is a math problem. It's not physics. So what I'm going to do is I'm going to divide each side by 8 pi. I want you to understand why I'm doing that, because it might be a little weird here since I have the pi over here and the 8 over here. So I want to solve for this r squared. So that means I need to get everything that's not an r squared over to the other side. It's being multiplied by pi and 8. So if it's being multiplied by both of those things, I need to divide both of those things off. The 8's will cancel and the pi's will cancel. So that's how I figured to do that. So then we get the r squared is 72 pi divided by 8 pi. The pi's are going to cancel here. You can use your calculator if you want, but I already can see that this is 9. And the reason why I can see that is because I just think of 80 divided by 8. That's 10. So 72 divided by 8, well, that's 8 less than 80. So I'm going to have 1 less 8. So instead of having 10 eighths, it's 9 eighths. So that's how I got 9. So if r squared is equal to 9, that means the radius is a plus or minus 3, because you take the square root of both sides. And if you have that the radius is plus or minus 3, of course we know that the radius is not going to be negative. That's not a real world thing. So from there we can see that the radius is 3. And it looks like that's our answer, right? No. No, it is not, because remember, we are talking about the diameter here. That's what we need. So remember that the diameter is twice the radius. So we need to multiply that radius by 2, and that'll give us that the diameter is 6. And that's the correct answer here. All right, so that is problem 49. Now we're going to move on to the last problem for this video. I don't know who's more excited, me or you. Probably me, because you still have an SAT to take. I now have to edit 50 problems, and then I got to put an intro in, an outro in. I got to put like an ad for my SAT course, and I'm probably going to do something else too. So that's going to take some time, but you have an SAT to take, and I think that's worse. So we are on problem 50 now. And this problem says, in the xy plane, if a point with coordinates a comma b lies in the solution set of the system of inequalities above, what's the maximum possible value of b? Okay, let's take this slow here. We're trying to find the maximum possible value of b. What is b? That's probably the first thing that you would ask there. Well, b is the y-coordinate of what? Well, it's a point that's in the solution set of the system of inequalities above. So we're asking, what is the largest y value in this solution set? So how do we find that? Well, honestly, just thinking about it at like face value, just trying to get a good picture of this in your head. You might be like, my dogs are barking. Like, I'm just trying to finish this video. Oh my God. All right. So as I was saying before my dog so rudely interrupted me, we're looking for that maximum y value in the solution set. So how do we find something like that? You might be looking for some different ways and it might not come to you. But if we have something that we can graph here, let's just graph it then. And maybe that will give some light on what to do. We're kind of just searching for different things that we can do here. And actually, if you graph this as a calculator problem, you could probably just find the answer that way. You probably could. I know the graph is a little bit messy with inequalities, but you could probably do it. But honestly, you don't even need a calculator to do this problem. And I'll show you why. You don't need an exact sketch of the graph. I'll just give one right here that'll give you enough information to solve the problem. Let's think about this first inequality here. Y is less than or equal to negative 15x plus 3,000. So we've got some positive y-intercept. It's 3,000 in this case, which is insane. But we have a negative slope, so let's draw that. So yeah, something like that, all right? On some scale, it will look like that. And how do we shade this? Well, it's all the y's that are less than or equal to negative 15x plus 3,000. So we're all these y's right here, all the y's that are beneath this line. All right, great. So now that we have that, let's look at the other one. That's 5x. So 5x, first off, the y-intercept there would be 0. And it's going to be something with some positive slope going through the origin. And how is the shading on this one? Again, it's less than or equal to, so we're going below this line. So it's everything underneath here. There we go. Nice and shaded. There we go. So since this is the y-axis, this is the x-axis here, we're looking for the highest value in this solution set. Remember, the solution set is where these two shadings are intersecting. That's happening right here. That's going to be where our highest y value is in this whole shading here. All these other y values are lower. And do you see what that is? That's the intersection of these two lines. It's the intersection of the lines y equals negative 15x plus 3,000 and y equals 5x. Remember, that can happen. These are less than or equal to. So part of the graph are these lines. So if we want to find that maximum y value, let's find where these lines intersect. Let's find exactly where this point is, and then just find what the y value is, the y coordinate is of that point. So we can do that because both of these guys are equal to y, so they're equal to each other. We set them equal. And now let's solve for x. I'll add 15x on both sides. That'll give me a 20x is equal to 3,000. And then I divide by 20 on both sides. When I do that, I get that, let's see, zeros cancel here. I have 300 divided by 2. That's 150. So is 150 my answer? Well, don't be so quick there. Remember what we wanted. We wanted the y coordinate. So we need to plug into, I think it'd be easiest to plug into the 5x. We need to multiply that guy by 5. So it's 5 times x is 150. So y is actually 750. That is the y coordinate of that point. And that is the answer for this final problem for the video. So yeah, guys, that is all 50 problems. And at this point, I am way too tired to do an outro for this video. So I'm going to leave that to my future self. I'll cut to that at some point here. So that is going to do it for this video. And remember, if you're looking to review more SAT math problems, specifically some harder ones, I have a whole nother video where I do 25 harder SAT math problems. And if you're looking for more help with the SAT, I go through every single topic that you need to know in my full SAT math course, which I've linked in the description down below. Lastly, make sure that you're subscribed to this YouTube channel. Look, you and I, we're escaping poverty together. You're going to get to go to the college of your dreams, and I am eventually going to be able to move out of my parents' house. All you have to do to make that happen is hit the sub button and share this video with anyone you think it could help. Alright guys, I hope this video helped, and I'll see you soon.